All right, so I'm going to officially get us started and hope Adi finds his way over as soon as he can. I'm Nina Axelson. I'm the president and founder of Grid Catalyst. We're a clean energy accelerator focused on demonstration opportunities and pathways for innovators with a focus on Northern Climate Solutions, being a Minnesota-based program. I'll talk a little bit more about Grid Catalyst after we do a little bit more level setting and introduction of our judges here in a moment. But I'm thrilled that we're able to be here on behalf of the Department of Energy and the Office of Technology Transition for the EnergyTech University Prize. So a reminder, we are recording the session. So if you really want to be able to share this out with a broader audience afterward, we'll have it up on our YouTube channel to share later. Hopefully all of our students feel really proud of the work they have done and their presentations today. So that'll be another way for them to share with their teams and teachers and other supporters. The program is in its second year. This is our second year hosting for the Northern Plains. So this Northern climate framing really works when we've got teams coming from North Dakota, Illinois, Iowa, Wisconsin, and Minnesota. So great representation here for the Midwest. We have several schools participating from the program, including a pretty large contingent from the University of Minnesota, but really excited to hear all the presentations today. So the way this will work is each student team has 7 minutes. We will cut everybody off at 7 minutes, so it's equitable for all the presenters. Judges then have 3 minutes for Q&A. I know that's really short, so I'm excited that the presentations are really effective, so hopefully we can get a lot done in the 10 minutes allocated for each team. And then there's about a minute for transition, allow the judges to make a couple notes in their scoring and allow for that transition to the next team. There's 12 teams presenting today, running a really wide gamut of technologies, excuse me, and solutions. So that's going to be really exciting. And then I'm really thrilled that at 12:30, we'll be able to hear from Anna Sifkin, who formerly was with Carnegie Mellon, and is on leave there to be at the Department of Energy in the Office of Technology Transition, and just is really an amazing expert working at the intersection of business, innovation, and energy. So what a perfect speaker to have for us today. And to keep everybody well occupied while our judges visit a different room to do their judging and come back, and we will announce the winner for the Northern Plains at the end of today's session. I know a few students have to drop off before the end. Don't worry, we'll let you know afterward what the results are. And I just really can't emphasize enough. I know that everybody's here to compete and you really want to gain a spot at nationals, but having seen the teams really do some great work over the short period of time that you've been involved in the competition, really commend everybody for diving in, especially those who are not from a STEM background. You'll hear Grid Catalyst talk a lot about we need everybody to do the work of the huge energy transition that's in front of us. So we really encourage folks who are in business and communications and the humanities. Like, we do really need all hands on deck for the innovation and the transformation ahead of us. So I'm glad that our students represent a wide variety of backgrounds coming into today. So that's the framing. One last kind of set of logistics for those in the audience. If you have a question, you can just go ahead and drop it in the chat. We'll be monitoring that, but the teams themselves will not be able to answer audience questions. If you find a technology that you are really interested in, thrilled that at least 3 of our teams last year had a follow-up from a corporate partner who was interested in the tech they were developing. We'll make sure to do that matchmaking, and I'll hopefully you're here because you have my contact information, but I'll drop my email in the chat as well to make that connection as smooth as possible. So with that, I'd just like to allow our judges to introduce themselves. If I started to introduce them, I'd probably spend 10 minutes on each person because they're all so amazing. But if each of them could just introduce themselves, and then I'll tell you a little bit more about Grid Catalyst, and then we'll get going with the pitches. So because Diane is on my left to right here, I'm going to ask her to start with a quick intro.
Thanks so much, Nina. Hi, everybody. It's a real pleasure to be here today. My name's Diane Rucker. Till recently, I led the incubator known as University Enterprise Labs, which was an incubator for startups in life sciences, biotech, medtech, and a few energy startups as well. I've been a mentor for CleanTech Open. I've worked in the startup ecosystem for roughly about 8 years, and my background is an executive MBA from MIT Sloan, where I was immersed in the startup ecosystem in Boston and Cambridge, and also worked with them in 2014 and 2015 on a regional entrepreneurship acceleration project, looking at how to accelerate startups in different regions around the world and really tap into their areas of expertise, which included everything from textiles to energy to logistics. Known Nina for a number of years, and I'm thrilled to be part of this and really excited to see what Grid Catalyst is doing to accelerate innovation in energy in our Northern Plains region. Very excited to be here today. Thank you so much for the welcome.
Thanks, Diane. And I am sorry you're sick, but hopefully you're on the tail end. So thanks for offering up your time and expertise with us today. Virginia, you're next.
Hi, I am Virginia Moody Rudder. I'm the Director of Engagement and Strategic Initiatives with Clean Energy Economy Minnesota, or SEAM. We're a nonprofit based here in Minnesota that makes the business case for clean energy, working with businesses across technologies, and really excited to see this innovation happening up in our Northern Plains region. It's so needed. So thanks, Nina, for having me today.
You're on mute. But probably
you knew that I was thinking of you next, right?
Yes, exactly.
The telepathy is strong here.
Well, hello everyone. My name is Adi Ranade, and I am a managing partner with a small company called 2 Degrees Adapt in the area of climate adaptation, resilience, modeling, and advisory. And I'm also on advisory board of Grid Catalyst. I love startups. Now I'm part of one. I used to be in the business of assessing them for a venture fund, corporate venture funds, etc. But I'm a climate tech professional for the last last 2 decades or so. My last day job was leading the energy division for the state of Minnesota Department of Commerce, and then my last corporate job was leading grid modernization, research and development for 3M. And Diane, I spent about 9 years in Boston before moving here, so we have something in common that I just learned. Great to be part of this, and looking forward to hearing about all the great ideas.
Thanks, Addie. You're the best. I am just really so thrilled to have this group of judges. I want to encourage the students that if you really got an extraordinary kick out of participating in this, and I hope you did, there are other folks in our ecosystem here in the Midwest who have the expertise of our judges, and that's part of what we're trying to do with Grid Catalyst, is connect you to, I love this, I'd love to be an entrepreneur someday, or I really like doing the research and I want to see how I can develop the intellectual property that's going to, again, change the energy system. There's so many different ways to participate, in this work. Some folks are really interested in being a CEO and being out in front and working on the business side of things, and others are really interested in delving deeper into the tech. And then we have some folks who love to do both. And there's a lot of other ways for people to be part of, again, this story and this work. So just encourage you that if you're in our audience, or if you're one of the students participating today, that we really want to see you explore this opportunity to the fullest extent. And we want to be here as a resource for you to connect you to these fantastic types of experts, but also the programming that can help you with where you want to go next. So that's a segue into just a little bit more information about Grid Catalyst. We might have some folks participating who don't know us as well. We were initiated in 2021 as a partnership with Clean Energy Economy Minnesota, which is where Virginia is connected to. And they really work at how to bolster the workforce and the businesses that help with that innovative future for the energy system. So we work a little earlier stage where we're trying to help those businesses get stood up, get those ideas out and deployed. So working on the earlier part of business development and tech and startup development. That partnership has been really important to us as we've evolved as a small business. We've got a few programs that we've developed in that time. I come from the utility and engineering world, and adoption of clean energy tech is not always at the pace that we need or that we want. And that's the point of an accelerator, is to say, where can we make this move faster, still including due diligence, still including risk management, all the things that we need to help technology move across the spectrum and into our daily lives to make a difference. So our initial program was focused on very late stage. We have a demonstration accelerator from 2022. We have 5 startups representing, again, another good range of technologies, including vanadium flow batteries, window glazing products, a grid forming inverter, geothermal, and actually an app for climate stewardship. So those projects are all in a pilot phase or about to start their pilot phase with partners in Minnesota. We have a really incredible presence here of organizations and institutions that also support innovation. And by becoming early adopters, that's a really game-changing way for them to step in and be part of this work. We have our second program up and running now, the Power North Incubator. This is for stage agnostic startups. So we have some really early stage folks who are just coming out of the lab with their ideas. And we have some folks who already have some pilot projects that are up and running. And once again, we're partnering with some of the biggest organizations, clean tech organizations in Minnesota, to help them advance even further, accelerating this transition and helping that innovation get into the marketplace. We really want to be a partner for folks at every stage, but we also recognize that the market needs a lot of late stage commercialization help. So that's going to be where we continue to focus. But every time I have the opportunity to work with students, I'm going to say yes, which is why I love being a host for EnergyTech University Prize. I have to tell you that the students that I've been able to meet with the last few weeks have just made me smile ear to ear. I love what you all are bringing to this work, and what a great way to kind of, I know it's almost the end of February here, but what a great way to kind of kick off the year with a lot of inspiration from you all. So with that, I'm going to invite our first speaker, I think it's Connor, to come onto the screen here, and we are going to get things started. Good morning, Connor. The stage is all yours.
We are here to talk about the carbon-free refinement of iron ore into steel using hydrogen plasma. So in a list of culprits for the climate change catastrophe, the steel industry would definitely rank near the top. The steel is traditionally made by reducing iron ore into pure iron via coal, which results in a large amount of CO2 released as byproduct. And last year's steel production accounted for roughly 8% of global CO2 emissions, which is about 3 billion tons of CO2 per year. But recently, however, a lot of governments have been making a push to halt all the greenhouse gas production, or at least alleviate it. The Inflation Reduction Act in the United States is one example of this, which calls for a 50% reduction in CO2 emissions by 2030 and net zero emissions by 2050. And this has made greener technology look a lot more enticing than ever, especially for businesses. Governments are offering credits sometimes for using this kind of technology, especially on such a large scale, like in steel plants. And other examples of agreements and international agreements was the Paris Agreement, which also called for reduced carbon emissions. So As mentioned, coal is typically the reductant of iron ore when producing steel with normal blast furnaces, but this releases CO2. And our technology instead uses hydrogen plasma to reduce the iron ore and only releases water as a byproduct. In laboratory tests that we've done, a 40-millimeter iron ore pellet was able to be reduced by 90% over the course of 35 minutes, and 98% purity is more than commercially viable in the steel industry. Our current reactors only run on a small scale since they're still experimental, but the current research is going into scaling up the technology. Our technology could have two major impacts. For one, less carbon production in industry that accounts for so much of the global emissions will definitely improve air quality. For one, preventing health issues. And for two, obviously, all the future climate risks that are associated with the ongoing greenhouse gas accumulation on the earth. And secondly, the technology could really reduce the cost of steel production. It cuts out the cost of buying coal, with the required material to run the reactor being hydrogen instead, which is a lot cheaper. And it's been able to reach a lot higher temperatures than the traditional blast furnace, which suggests that it could be a lot more efficient. And one thing we did want to mention is that much of the hydrogen that's currently used in other processes is produced and stored with carbon emissions involved in making it and storing it. And so we plan to only source our hydrogen from clean hydrogen producers to make sure that our whole process is green and efficient. So the materials for the technology are pretty cheap. The main heating component of the reactor is essentially the same equipment as a kitchen microwave. And we, of course, also need to source hydrogen for the reaction, as I mentioned, and we'll also need a noble gas source like argon, which are both relatively cheap. We think that as the scale of the technology increases with our research, the efficiency will also increase and the relative cost will decrease. And the technology is also modular, which means it can be turned on and off whenever to conserve energy, unlike a blast furnace, which must constantly run. It's also important to consider that a lot of taxes for carbon emissions have been imposed in Europe over the last few years, and the United States is likely soon to follow and already looking at these sorts of taxes. And so if businesses can get a jump on clean iron reduction, they'll avoid unnecessary costs when that happens. And as for our sort of general place in the market, some laboratories are working on developing similar technologies with hydrogen plasma. There's the Max Planck Institute in Germany, which is working on something similar. But ours is going to be the first attempt at hydrogen plasma steel production in the United States. And some technologies, other sorts of iron reduction technologies have recently been popularized, which try to alleviate the carbon emission problem, like the electric arc furnace, but none of these are completely carbon-free like our technology. And one thing I did want to mention is that we have a localized advantage being from Minnesota. Minnesota is, by some metrics, the largest source of iron in the United States. We have a lot of sprawling iron ranges like the Mesabi Iron Range, which I have pictured there on the screen. And these iron ranges are usually pretty rich in the hematite form of iron ore, which blast furnaces are not able to readily reduce in their method, but hydrogen plasma can reduce this. It can reduce magnetite and almost all the other forms of iron ore that are available. So our overall goal as a business is to see our hydrogen reactor technology overtake the blast furnace as the dominant method of steel production in the United States, and then maybe move globally after that. And to get there, we're definitely going to need a lot of help from investors, the public, and governments. Some research has yet to be done, as I mentioned, mostly about how to scale up the technology. But we hope to start receiving interest from governments soon and believe the technology can be scaled to a point that matches blast furnaces production within about 10 years, 5 to 10 years. And given the huge environmental impact this technology could have, we also really do want to advocate for its benefits for the planet and show the public why our technology matters. And we think this is definitely going to make such a novel technology a little easier to implement, seeing the actual practical benefits of it. And finally, we plan to implement the technology by making deals with newer steel plants, which we think will incur a greater advantage to having this due to their longer lives. It doesn't make much sense to replace the technology in a steel plant that's about to close down. And we think gradually replacing the blast furnaces rather than all at once with the hydrogen plasma reactors, so that the steel plants can still run their blast furnaces while the hydrogen reactors are being set up, is the way to go with this. Thank you for listening, and I am open to take any questions now.
Thank you, Connor. Great presentation. Not surprising that Addy already has his hand up, so I'm gonna turn it over.
Yeah, great presentation, Connor. I'll try to great presentation again, and thanks for attacking a big problem. I'll limit my questions to two. One is, I didn't quite get, where was the technology developed? Was it developed in a university lab? And do you have any intellectual property protection on that? For example, a patent application? And then my second question is, within the United States, do you have a target market? Are you focusing on Minnesota, any particular state, or have you had any conversations, early conversations with the likes of Cleveland Cliffs or US Steel?
Yeah, so the prototype was developed in the University of Minnesota laboratories. I'm not sure if they ended up getting a patent for it at all yet, but I'm pretty sure that something was being worked on, because it is a pretty important technology. I'd imagine that's something they're working on, but that isn't something that I specifically asked them. So my apologies, I can't answer more specifically than that. But as for the target market that we're looking for, I know there aren't a ton of steel plants actually within Minnesota, but since Minnesota has such a benefit for having all its iron ranges, we think we want to kind of start within the Midwest and then work our way outwards, sort of.
Makes sense. Thank you, Connor.
Yeah.
Thanks, Connor. Diane, you have a question? We've got about a minute and a half left of Q&A.
I do. I'll keep it quick. The steel industry has been very slow to adapt new technologies in the past. What is your plan for finding and working with partners who can help you get this accelerated?
Yeah, well, I think a lot of it is, I mentioned that we really want to like make we want to do a lot of advocacy for it and like get the public involved in it, so it becomes less of like, I know there is a lot of difficulty in adopting new technologies, especially when there's such a large scale thing. We kind of want it to be a little bit more normalized by making it more just accessible knowledge in the public, and we plan to kind of just like work with individual companies, see who we can strike deals with, instead of tackling like biting off more than we can chew, so to speak, by going for a bunch of different steel companies at once.
Great. One more quick follow-up. Is it only for new production, or it can be used for recycled or repurposed steel?
I believe it can only reduce iron ore, not the actual repurposed steel. I'm not sure. I would have to verify about that.
Awesome. Thank you so much.
Yeah, thank you.
Great job, Connor. Great use of the time, judges. We've got a minute of transition, and then we will go to Mackenzie. So wonderful job, Connor.
Thank you.
Thanks. Mackenzie, you can go ahead and get your slides ready to go, but just hold off about 20 more seconds before you load them up. And just a reminder for folks who are less familiar with the EnergyTech University Prize, this is a wonderful merging of technological advancement and innovation with a focus on the business plan. So we really are trying to bring these things together, and I appreciate OTT's emphasis on, we know there's lots of great tech. How are we going to get it into the marketplace? What are we going to do to make sure these things become businesses? Because great ideas dying on the vine is the worst case scenario for us, right? So I love this part of the challenge for the students and for this program. So commend OTT for making that focus. Mackenzie, you can go ahead and load up your slides and get started.
All right. Hi, my name is Mackenzie Short, and today I'm going to be presenting our business idea on next generation biomass derived materials. Our team is Sustainable Heroes, and our mission is to move towards a carbon neutral environment by sequestering CO2 in marketable products that can be easily integrated into our infrastructure. There are so many sectors of our modern economy that contribute to the current problem of rising greenhouse gas emissions. The agricultural and industrial sectors alone represent 45% of our global greenhouse gas emissions, with the production of cement being responsible for 8.6% of that. 50% of the emissions from the cement production comes from the energy used in the breakdown of limestone into usable products. And the other half is from the breakdown of limestone itself. As limestone goes through the calcination process, it breaks down into lime and CO2. So our vision is to design a material that would sequester carbon, prevent landfilling or burning of biomass waste, and serve as an alternative to conventional concrete. So a group of us working under Dr. Surjit Gupta at the University of North Dakota has developed a proprietary concrete alternative made of 100% biomass. Our material has strength comparable to that of structural lightweight concrete, and this strength can be tailored depending on the processing temperature. We utilize biomass from a variety of sources, including corn husk, wheat straw, flax straw, even sunflower hulls. Our raw materials can be sourced at low cost from farmers and food processing facilities. This brings in extra revenue to support our farmers. Another thing I'd like to just emphasize is that our processing temperature can be as low as 300 degrees Celsius, depending on the strength necessary for the building material. So comparing this to the 1350 degrees Celsius required for Portland cement, this results in a significantly reduced energy input, leading us to a more sustainable infrastructure. During our market assessment, we found that there is increasingly high demand for green building materials. There's a couple companies that have started something that's called hempcrete. It's a biocomposite construction material made up of hemp curds, lime, and water. It's more sustainable than traditional cement concrete. However, it still has that lime, that calcination process to get the lime. What we didn't find during our research was a company that has a 100% biomass alternative. So essentially we have no direct competitions there. Our biomass market is actually very large, as the biomass waste in the US is expected to reach 1 billion tons by 2040. This results in very attractive returns to farmers for biomass harvest, as they could sell their biomass from anywhere for like $30 to $60 per ton. We've also received several letters of endorsement from farmers in the North Dakota and Minnesota areas. Once our main product line is up and running, we have plans to expand into the biofoams sector with oil spill cleanup and filtration systems, as well as bio-based coatings such as paints, lacquers, and resins. Our lab group has done extensive research in these areas, and I'd like to make note that the global bio-based coatings market is expected to grow from 6.37 billion in 2021 to 12.79 billion in 2026. Our financial projections were done for our initial pilot plant operations, where we would produce 3.7 million bricks in a year. This would bring in about 4.8 million in revenue, giving us a gross profit margin of 25%. And then we would scale up within 2 to 5 years, which would significantly reduce our cost of production. Our current research is funded by the Agricultural Product Utilization Commission. However, once we get closer to our pilot plant operation and commercialization, we'd be looking into federal funding agencies such as DOE, SBIR, and STTR programs, as well as angel investors. This project was started in September of last year, and we have already achieved technology readiness level 2. And our goal is to reach TRL 6 by 2024. Our hope is that with the establishment of our pilot plant, we can reduce North Dakota farmers' biomass burning by a quarter within 2 years. This is our team. As you can see, we have a very robust team of scientists and engineers. We also have our board of advisors, including Dr. Gupta, Dr. G, and Dr. Zhang. For our staff resource plan, our plan is to bring on some interns during technology or TRL 4, just to help with the upscale of our product. And then TRL 5 and TRL 6 will bring in some safety officers and operations personnel, just to get that pilot plant operational. Our company is going to have some major impacts on the planet. We're going to see a lot of benefits for society with the increased revenue for farmers, reduced health problems due to pollution, as well as the creation of new jobs. We're also going to see some benefits to the environment with the improvement of air quality, reduction of emissions, and waste reduction. And lastly, we're going to see some benefits for the economy as we convert waste to wealth, advance the sustainability of infrastructure, as well as providing our farmers with attractive returns for their biomass harvest. I'd like to thank you all for attending, and I am now open for questions.
Great job, Mackenzie. Virginia, we're going to go to you first.
Thank you for your presentation. I thought it was great. Wanted to hear a little bit about kind of the ability to pivot to other kinds of biomass stocks. So whether it's like a woody biomass or something harder, I guess, than the stocks that you had talked about, and then also the radius of like how far away from the plant will you be receiving biomass?
Okay, so we're actually flax straw is a pretty woody, tough kind of material. So that's one of the materials we're using. So yeah, we can definitely use those more woody materials. We can also use like the softer materials such as like the hemp hurd and corn husk and whatnot. And then for biomass, we'd be focusing on the North Dakota, Minnesota region to start off with our pilot plant. But as we begin commercializing, we'll start other plants in other locations, and then we'll start utilizing biomass from other regions as well.
Virginia, any follow-ups?
That's good.
Addie? Got a minute 40.
Okay, great presentation, Mackenzie. And I had a question about maybe indirect competition in the low carbon concrete, cement concrete area. What do you think about direct carbon dioxide injection into cement concrete? Companies like Carbon Cure, Solidia are getting a lot of traction. How would you compare your technology with that?
So one thing that's like the hempcrete, the hemp in the hempcrete actually sequesters some of the carbon. So we'd be having a similar thing going on with our material. Also, we're preventing a lot of that biomass from being burned, which is another way that we're reducing emissions. And then just the complete replacement of lime use in cements and concretes. That's going to be probably one of the biggest areas where we're going to see the change in emission levels.
Great. Thank you.
Diane,
Great.
if we could cover it in under 30 seconds.
30 seconds quick. Is there any degradation over time to the biomass materials that you use in coatings or blocks?
We are still in that phase of research, but we still need to test it in like a real world environment. But we've established that we have the strength needed. And yeah, so I guess there you go.
Thank you, Mackenzie. Great job. We've got a minute for our judges to log their scores. And then Melanie, if you could come on screen and let's get your slides up and ready this time. So I'm realizing that that's taken just a little extra moment. I don't want it to cut into your presentation time. So. All right. So Melanie, why don't you go ahead and get started? Your 7 minutes are on the clock.
All right. Methanol to bethanol is a pretty silly title, but what isn't is the amount of harmful toxins that are being released into the environment every day by inefficient fuels used by shipping companies. The fuels used by maritime transport companies specifically are some of the most harmful and lowest quality of any other fuel source. It has even reached a point where these fuels have started to impact and negatively impact the polar ice caps and their melting. This stems from sources like the ethanol plants who are producing some of the fuels as well as carbon dioxide waste. Our mission is to use this underutilized CO2 to create green methanol for carbon neutral shipping. Currently, about a third of the inputs for ethanol production are released into the air as a form of carbon dioxide. The primary problem is that these emissions represent a pretty big inefficiency for ethanol producers, but they are also a factor for pollution and even things like climate change. A secondary problem is that the environmentally harmful and low-grade fuel that's being used by current maritime shipping companies is really bad. With Minnesota and the Midwest making up most of the US's ethanol production, we see this as a pretty important problem in our area that needs to be addressed. We are going to address it by inserting ourselves in this area of the ethanol production line, which we've highlighted at the top in the lines. When corn is used to produce ethanol, carbon dioxide is released into the atmosphere. Our process captures the CO2 before it is released into the atmosphere and then converts it into methanol using a green hydrogen source. This green hydrogen can be outsourced from things like the Midwest wind energy plants. This process allows us to gain more input from the same amount of biomass input. This would increase the production capabilities as well as make the ethanol plants much more efficient in their processes. This not only helps the environment by producing greener fuels, but it also helps the ethanol companies and those who buy from them, like everyday customers, show that they care about the environment. Now, you might be asking how economically feasible this is. Well, a typical ethanol plant produces about 100 million gallons of ethanol per year, and that's about 290,000 metric tons of CO2 being released. This amount of CO2 could yield up to 210,000 metric tons of methanol. This is about roughly 7 million gallons of methanol that could be produced per year. This can power about 3 maritime transport vehicles or boats per year. The methanol produced could be sold between $14 and $21 per gallon of methanol. As we stated previously, the hydrogen which we would need to have outsourced would cost about $4.20 to $6.30. After factoring in the cost of hydrogen from the methanol revenue, we estimate a potential profit of $7.70 to $16.80 per gallon of methanol. This excludes the limited costs of implementing the technology, which would be recovered in the first year from the methanol profit. When taking into account the large scale of ethanol companies and the fact that most of them have more than one ethanol plant, this incremental revenue adds up pretty quickly. How are we going to do this? So first, we're going to obtain long-term contracts with ethanol plants for implementation and upkeep of the technology necessary for the process. The Midwest contains many ethanol production companies, and we can target some of them, such as Poet Biorefining. Poet Biorefining has 33 plants across the Midwest alone, and right here in Minnesota, there are even 4. Next, we will help to implement the technology into our customers' ethanol plants and provide continued upkeep. Our company's profit would keep coming from a fraction of the profit we would take from our customers and continued maintenance fees. The Inflation Reduction Act has made it so that our customers and the maritime transport companies who would be using the recycled methanol could receive part of the $369 billion of green energy incentives that include carbon capture technology. Our primary customers would be the ethanol production companies wishing to implement greener technology, but our secondary customers would be maritime corporations such as Maersk. Maersk is an international shipping company that has a carbon neutral promise by 2040. Now, who's trying to sell to Maersk? Maersk has said on record that they're having a really hard time finding companies who are trying to sell them green fuel to power their carbon neutral ships. There's one company based in Denmark named European Energy that has the potential to sell Maersk methanol. However, nationally, there isn't a lot of competition and there are not many companies making green methanol as fuel. Maersk's promise entails such a large amount of methanol input that even if they bought from the Denmark company, they would likely still need more fuel that they could get from our customers. Once the contracts are established and agreed upon, the technology itself is relatively straightforward. The technology for the entire process already exists and is very well developed. After the carbon is captured, we would need to set up a process for transporting the outsourced green hydrogen into the methanol plants. From there, the CO2 can be converted to methanol, generating revenue for our company and our customers who are selling it to maritime transport companies. Not only would it be generating profit, but we would also be improving upon the environmental distress that is being caused by maritime transport currently. The development for greener fuel is only going to get more desirable as time goes on. And as the global sustainability movement grows, there will be even more opportunities for expansion. This process seizes upon one of those opportunities that can even affect us at the level of our homes here in the Midwest. Thank you for listening, and I'm open to questions.
Great job. I'm impressed with the presentation and the time. Judges, does any, Diane, I see a hand.
Excuse me a second. I have a question, and it's regarding what is the growth of the methanol market expected to look like? So as you look at a market assessment for both ethanol and methanol, how do those compare over time? And do you see the growth of the methanol market being enough to support the recycled or green methanol that you're going to be creating?
Yes, so big companies such as Cargo, which is probably one of the biggest ethanol companies, has said that they're trying really hard to expand into greener fuels, and they have mentioned methanol in the past. Also, specifically for shipping companies, methanol has been stated as one of the fuels that they're looking to go into because it greatly reduces the amount of sulfur being released. And it would also help with the problem of black soot being released when these maritime boats are traveling, which would help with the melting of the polar ice caps as well.
That makes sense. But again, have you looked at the growth of the methanol market over the next 5 to 10 years?
I have looked at it a little bit. Unfortunately, I don't have specific numbers, but we have seen a growth in the past few years that shows future improvement in growth.
Okay, thank you.
Addie.
Yeah, great presentation, Melanie. My question is, now how would you compare methanol versus ammonia as a low carbon fuel for shipping, since that's your target market?
I don't know that much about ammonia specifically, but I do know that methanol as a fuel, the main concern with the shipping is not only the carbon emissions, but also the other byproducts that are being released. And the fuel that is currently used is kind of the bottom of the barrel fuel, and it's releasing so many toxins that any kind of alternative fuel has a really big market right now. And methanol specifically has a lot lower sulfur emission and a lot lower soot emission. So I'm not sure how ammonia would compare to that, but those are some of the big benefits for methanol.
Yeah, one of the technical metrics to compare it against would be, energy density, so energy per liter. And I think you may find, I've just heard a lot more about ammonia than methanol for shipping fuels, but I think that I believe you should check this, but methanol has more energy per liter per volume, so you should look into that.
Thank you.
Thank you, Addie. Great job, Melanie. We're going to give a minute for transition here. So if Matthew could come on video and get his slides ready to go while they deliberate. Thanks. I guess not deliberate, but put in their scores. Usually I'm better at some filler content, but I'm so focused on all the timing and the slides, everything else. I realize hopefully everybody feels just full of content from these exciting presentations already. They don't need my filler. So, all right, Matthew, about 10 seconds, then we'll get going here. I'll put you on spotlight. All right, take it away. You got 7 minutes.
Hello, we are Team Helios from UW-Madison, and the technology we're presenting is a low-cost heliostat for industrial process heat. So to introduce the team, I'm a graduate student at the Solar Energy Lab at UW-Madison, which has jointly developed this technology along with work done at NREL. And I was assisted in the economic analysis by Cole and Wyatt from UW-Madison Solar Energy Club Helios. And Simon and other members of the club have also been involved with the physical prototypes that we have with the technology. So thanks to them. So what is concentrating solar power? What is a heliostat, and why is industrial process heat important? So this is a picture of the Crescent Dunes Solar Power Tower in Nevada. And basically it's a field of tens of thousands of mirrors or heliostats that focus sunlight onto a central receiver. The advantage of this over solar panels is that the plant can store its energy overnight in molten salts, and it can achieve much higher temperatures and higher efficiencies than solar panels, meaning less land area is used. But as you can see, these heliostats are massive. So not only do the components cost a lot of money, but so does the installation and on-site assembly of these things. So how is our technology better? Well, I can't show you a picture of the prototype because we're still working out the IP, but essentially they're smaller, modular, and easier to install and source components for. Our innovation reduces the cost of the motors, which results in a lower dollar per meter squared, as you can see on this graph in the third bar. Our design is meant for small fields, so 100 kilowatt to 1 megawatt, which is an unmet niche market, because while all towers that currently exist generate electricity like the one I just showed you, we'll focus on supplying high temperature process heat, which is an unmet market at this temperature range. Our tech does have a lower field efficiency, which results in slightly larger field sizes, but at the end of the day, we're targeting a cost of energy delivered at 5 cents per kilowatt hour thermal, and you'll see why that's cost competitive in a few slides. So who cares about process heat? Well, 20% of all CO2 emissions are just from industrial processes like we've seen in previous presentations, like for the production of concrete and glass. And even if we do completely decarbonize transport in the grid, we don't have real solution for this at a broad scale. And here's the breakdown by sector. So based on some preliminary customer discovery interviews and the temperature range, these are the markets that we're targeting. But where is this happening? So we reached out to a glass manufacturing plant in Arizona and a silicon wafer manufacturer in the Southwest due to the solar resource and the prevalence of the semiconductor industry there. But really any place in the orange might be worth pursuing, especially if there were carbon tax credits or something similar, especially for new plants, as there aren't that many plants for float glass creation, specifically in the Southwest at least. So who's our competition? The closest commercially available heliostat and a good baseline is the Stelio heliostat by SPP. The Sun Ring by Solar Dynamics would probably be a competitor, and they're developing this for market right now, but these numbers that are here are for large field simulations, and ours achieves a similar price point per meter squared for smaller fields. And the metric that really matters is that dollar per kilowatt hour thermal, regardless. So what would our tech be supplementing or replacing? One area we looked at is electric arc furnaces. So these typically melt metals such as for steel recycling and silicon wafer production in batches, and often run during times of low electrical costs to save money anyway. So that pairs well with the cost and intermittency of solar power. Market that would be tougher to crack due to the price is any high temperature furnace that uses natural gas, such as in the glass making industry, but our tech falls within those price ranges as well. So we did some preliminary customer discovery interviews to gauge which path it made sense to go on. And we were fortunate enough to talk to the head of heliostats at Heliogen, as they're the primary company in this space. We were surprised to learn that they would be open to licensing or some kind of agreement if the dollar per kilowatt hour thermal was significantly better than existing technologies, around 20 to 25%, but that was just like a ballpark number, and I really wasn't supposed to quote that exactly. And I guess this makes sense though, because even though Heliogen's main tech is their heliostat, their modeling and machine learning and automation software is independent of any specific heliostat design, which is the main sell of their company, and they have been iterating on that. We also received some positive feedback with the direct route, even though starting a company is far more difficult than the first strategy. But we spoke to a plant manager at a glass tempering facility in Casa Grande, Arizona. He was very open to working with researchers, although he had some doubts that the temperature range and power requirements could be achieved. So we would likely need to show some proof at a small scale before moving forward. And he also thought our technology would be a better fit for float glass rather than tempering the glass. And we agreed, so we identified a plant in Oklahoma that would likely be the first customer. We did some very rough estimation of the steel recycling and silicon wafer industries to see if there was a market there. The data for steel was pulled from Nucor, which is the primary steel recycler in the US, and assuming we save like 25% on the energy costs of one of their 70 or so plants, then given an 8% internal rate of return and a 5-year investment, that more than meets the cost of the heliostats. The numbers for silicon wafers are a lot harder to come by. And while we tried reaching out to one manufacturer, Sumco, located in Phoenix and Albuquerque, because they're technically a defense adjacent industry, they couldn't share too much information, but based on what we could figure out, power requirements are also fairly reasonable at the 100 kilowatt or so scale. So where do we go from here? Well, our 5-year plan is to continue doing customer discovery interviews while completing the detailed techno-economic and optical modeling, so we can give a more concrete answer on the actual dollar per kilowatt hour thermal and other metrics that we can deliver. Then we'll hit a pivot point where we either decide to partner with an existing company or form a university spin-off company and make a few heliostat kits essentially. Then we would have to perform some fairly standard tests in a very small scale demo field to ensure that the optical errors agree with our models and pricing. And after that, it's deploying them in a commercial plant and dealing with all the fun troubleshooting involved. And if the venture isn't met with any pessimistic news headlines 1 to 2 years after deployment, then I would consider that a success. Thank you for listening, and that's all I have for today.
Great job, Matthew. Our judges, you have 3 minutes to dig into that great presentation. Addie, I think you've got the quickest hands up button there.
I want to make sure I give a chance to our other 2 judges too. So I'll be quick. Great presentation, Matthew. Glad you're already talking to potential customers. What's the total impact, right, in terms of CO2 removal, or you started alluding to that, but let's say if your company is wildly successful, right, in 5 years, what kind of impact will you have?
Yeah, so I guess wildly successful in 5 years, I'm more of like a pessimist, so I'm assuming that it's like the only thing that like within 5 years we would ideally like have a partnership with like that Oklahoma plant or something like that, and be reducing as a percentage their natural gas use or something like that. So I mean, it's not changed the world within 5 years, but I mean, I guess the eventual goal would be that 20% number for the total global carbon emissions, which is all this industrial processes. I probably should pessimism though here.
That's not necessarily a bad thing.
Yeah, I think my question was similar. Just like the savings, I assume, are the offsets of the electricity that they were already using. So whatever source they had.
Right, yeah. Either electricity for the steel recycling and the silicon wafer plants, or natural gas from the like other industries like cement and glass.
Great.
How widely are heliostats currently in use in different parts of the country or different parts of the world?
Oh, how wide? How this specific type of heliostat?
Either the specific type of heliostat that you're creating or the one that you're replacing. How
okay.
widely is that currently in use, and how much energy does it generate?
Yeah, so for this specific market, there's really no like it's kind of like a new market. For just concentrated solar powers in general, there are 2 plants in the United States that are like millions of square meters. So lots of, like, many thousands, I suppose, if that answers your question.
It does. I was just kind of looking for a scope and scale of how much is out there. Thank you. Great presentation.
Great, Matthew. Thanks. We are in that transition minute, and we will have Gwenny up next here. So if Gwenny, you want to get ready and get your slides ready to go. As someone who worked on the heating and cooling side of the energy industry for a long time, I love a presentation that asks the question, who cares about process heat? Because I can say, I do, yes, nerd out about process heat all day. So if you were wondering how nerdy your host was, that's the reveal. So got just another moment here before Gwenny starts. Going to start talking a little bit about EnergyTech UP in between some of our pitches here. And so just a reminder that I put the link in the chat if you don't know about OTT in general and the great work that they're doing. EnergyTech UP just being a component of that wider work. So just want to make sure we're giving you lots of information today. All right, Gwenny, I'm going to put your spotlight on and you can get started.
Perfect. So my name is Gwenny and I'm representing my company, Nano Blue Skies. During my pitch today, I will demonstrate how nanotechnology can be used to effectively capture carbon and lead to a sustainable future. So our team aims to take this technology into Mars, and we see NASA as our first customer because they are already dedicated to making journeys to Mars. Before explaining the technology and how it works, I want to give you some important facts about Mars. So the inevitability of an asteroid or a catastrophic event for our Earth has really just spurred scientists, billionaires, and people around the world into researching the possibility of establishing a colony on Mars. And scientists just claim that Mars is where the science, challenge, and the future is. So NASA has already dedicated themselves to developing the capabilities needed to send humans to Mars by 2030. And Nano Blue Skies aims to take our technology to Mars, and we see NASA as this main customer. But there are a lot of challenges that we need to address. And the most important is that carbon dioxide makes up about 96% of the atmosphere on Mars, which is fatal to humans. And oxygen is only about 0.13% on Mars compared to Earth's 21%. So to be able to live sustainably on Mars, we will either have to bring our own oxygen or find a way to create it on Mars. So this is where our technology at Nano Blue Skies comes in. So Nano Blue Skies directly converts carbon dioxide into oxygen. Utilizing lab-on-a-chip development, we would encode the chemical pathways of photosynthesis from the bacteria Prochlorococcus onto silicon dioxide nanoparticles. And these nanoparticles would then take in CO2 and sunlight and then perform photosynthesis and then produce the byproducts of water, oxygen, and the carbohydrates. So this technology would be 9 times more efficient than natural photosynthesis, and the nanoparticles themselves are very scalable and don't require any energy generation. So then onto our business plan, we want to develop this technology in-house, and then we would like to license it out to NASA for utilization on Mars. Once this relationship is established between NanoBlueSkies and NASA, we can then expand the technology and work with NASA to address climate change here on Earth. NanoBlueSkies can be used as a carbon geoengineering activity or as a supplement to traditional carbon capture, utilization, and storage technologies for a sustainable future here on Earth. So moving on to our go-to-market plan, the first step is assessing the needs of NASA. NASA clearly has a need for this product, and even though they have been working on a similar product with the carbon-to-oxygen technology called MOXIE, it is not as efficient as our technology is. MOXIE only produces oxygen at a rate of 6 to 8 grams per hour on a lab scale, which is not sufficient enough to sustain life on and travel to Mars. So then our technology outperforms MOXIE at a global scale. We would eventually produce enough oxygen to meaningfully change the atmospheric composition of Mars. Our technology is better than competitors because it is very scalable, as I mentioned, and is only a $288 million cost for each 1% of the atmosphere to be covered. We are also utilizing natural earth-abundant resources, which cuts down on expenditures as well. Overall, we plan to manufacture around 72,200 metric tons of nanoparticles for the first 1% of Mars's atmosphere. And then we would only have to bring the equipment for making the nanoparticles on the shipments to Mars because Mars is already abundant with silica, which is the material that makes up our nanoparticles. So then for the second part of our market plan, we have decided to engage in B2B marketing because this increases our brand recognition and really just helps convince investors to engage with us. Specifically, we want to attend the 26th annual Mars Society Convention held in Arizona, as this will be a perfect opportunity to connect with NASA about Mars and our technology's value. And then, as I mentioned earlier, once we have secured this relationship, we plan to implement our technology in conjunction with current carbon capture technologies on Earth to address climate change issues here. So then moving on to some financials. As I mentioned, we want to license this to NASA. So within this licensing agreement, NASA will use our intellectual property for a royalty rate of 25%. Therefore, 25% of the operating profit of the product will go to NanoBlueSkies. The nanoparticle industry is growing, and according to a report from the BBC in 2018, it is expected to more than triple in growth in the near term. So from that projection, we've drafted a hypothetical financial timeline for the first 10 years of licensing. So looking at the expenses, our research puts a nanoparticle fabrication plant at a cost of around $214.6 million. And we've also calculated the cost of manufacturing enough nanoparticles to cover 1% of Mars's atmosphere. And this cost would again be $288 million for the 72,200 metric tons of nanoparticles. And this figure is really just convincing because we drew on calculations and estimations done in semiconductor development, which at this point is a well-developed field that we can rely on. And the fundamental concepts of semiconductor development are closely related to nanotechnology development. So then that $280 million number, along with the $215 million cost for the fabrication plant, brings expenses to around $500 million. And then taxes would be around 30% of the operating income. So that would bring our net income to about $263 million for NASA after the royalty payment that they would pay to us, NanoBlueSkies. And overall, the return on investment really just comes from government operations of colonization efforts. So NASA will see increased profits the more they make the planet more habitable. So then moving on to a timeline, I just want to highlight a few key activities, and we've based these on the estimation that humans will be able to fly to Mars beginning in 2030, and that gives us 5 years to test our technology in a controlled environment and obtain a licensing agreement with NASA. Because it will be so long before we actually start producing for NASA, we want to explore other options on Earth during those 5 years as well, such as pairing with breweries to... Sorry,
Thanks,
did the screen sharing stop?
Yep, Gwenny, you're at 7 minutes.
Perfect.
So
Sorry about that.
that's okay. So we're going to start our 3 minutes of Q&A. So if judges have questions about kind of where you are going, they're welcome to ask that, but otherwise they can dig a little into the big topic of nanotech.
Yeah.
Virginia?
Sure. I am just interested to hear from you why you would start with building it on Mars and versus starting with carbon removal on Earth.
Yeah, so when we were doing our research, we kind of saw that nanotech is like such a new concept, and we figured that we would only be able to get interest from like bigger people like government or like large corporations, and we decided that NASA would be a good like entry into this world. And as I was like about to talk about, because we wouldn't be able to send a NASA into Mars until like 2030, we would explore like some options on Earth as that beachhead market before 2030 within that 5 years. But we thought getting this licensing agreement with NASA would open up like more opportunities in the future as well, because there's such like a known company.
Okay.
Virginia, follow-up? No? Okay. Diane?
Thank you very much for the presentation. Like Virginia, I was also curious about earthbound applications. You mentioned breweries. Are there other ones that you're looking at that you can share at this time?
Yeah, so the breweries with the CO2, and then we were also thinking about offering it as a solution to big like corporations like airlines that produce CO2 and can't really like stop that because it's like a big part of their operations. So it would just be kind of like an offset option for them.
Thank you.
Virginia?
You talked about the material need for like the nanoparticles as a silica base. Have you looked at availability of that here on Earth? Because I know you said Mars has a lot of it. So like what would the market opportunity be? How much would you be able to make here?
I believe it would be pretty abundant because it is like something that we have on Earth, like the sand particles and everything. I didn't look into exact numbers, but I do know that we had originally been looking at gold nanoparticles, and I know that the silicon ones have like a way higher amount for the materials than the gold does.
Great. That's our time. Great job, Gwenny. Appreciate you digging into a really interesting topic. Judges, you've got a minute to log your scores. So I'll have Aman come on screen and get your slides ready. And for those joining who haven't spent a lot of time looking at the framework for today's event, you're just really interested in the tech, there is a framework here for the EnergyTech University Prize. So putting the link in here that these students are competing for prizes, both in the Northern Plains region, as well as in regions across the country, and vying for a chance at nationals. There's also some really interesting department or technology specific prizes. So really interesting to see such a wide range here because they could be competing against each other in our region and nationally. But as it comes to the technologies, they all might have a separate lane. So, all right, great. Aman, you can go ahead and start.
Hi, I hope everyone's having a great morning today. Today, Tally, my teammate, and I are presenting a solution that takes us one step close to a net zero future. We are presenting a novel solution for lithium extraction from geothermal brines. We all know how important lithium is in the world today. Its demand is going to increase exponentially, approximately tenfold in the next 10 years. And given the state mandates passed by the governments to have all new vehicles to be EVs in a lot of different states, the demand for lithium and lithium-ion batteries is just going to increase furthermore. The demand for lithium is approximately 0.3 million tons today, and is going to increase to approximately 2 million tons in 2030. However, the problem we are tackling is with the current method of extracting lithium in the world today. It releases enormous amounts of carbon, uses tons of water and land, and is also a very big human rights issue across the world. The solution we present has minimal water and land usage, has zero emissions, while we also simultaneously generate a lot of clean energy. And our solution directly aligns with the sustainability development goals listed by the United Nations. Our solution is a two-pronged solution we present. For context, current geothermal plants tap deep into the ground to access geothermal brine, which is a saline solution which is turned to steam because of high temperature and pressure to turn a turbine to generate clean electricity. However, there is a rich and a very high untapped source of lithium which can be extracted using sorbent materials which can hold lithium in its purest form while simultaneously generating clean electricity. This lithium can then be supplied and extracted and can be used in electronic vehicles for its batteries. It's exciting to think how lithium was conventionally sourced by digging down, but now we will have lithium coming right up to us. The current prices of lithium are off the roof, and a solution can potentially extract lithium at a 20% cost in comparison to the current prices. The current capacity in the US is about 5,000 tons, which is predominantly extracted and mined in Nevada. However, our solution can have a capacity of roughly 30 times more. For some more context, our technology will only take roughly 53 seconds to get enough lithium for one EV battery. So we know how much lithium we can generate using our technology and how much potential there is for the future. The USA roughly accounts for 1% of production today in the entire globe, and our solution can allow us to capture a 12% market share in the upcoming years, which can allow us to scale up our market from roughly $300 million to $4,000 million in the upcoming years. No one in the world has implemented this technology so far, which makes this a truly innovative solution, giving us a first mover advantage, which can allow a reduced dependence on imports in the future, access to cheaper and cleaner sources of lithium, while significantly improving conditions in which lithium is mined, because that cost is not included anywhere in the price of lithium. Looking at this graph, we can see a very high correlation between the lithium deposits around the world and the geothermal potential, especially in the west coast of our nation here. Our first target market would be the west coast of America, which is also very close to EV manufacturing facilities, so that we can extract lithium very close to the EV manufacturing facilities, so that there can be potential tie-ups between EV manufacturers and lithium extractors. This high correlation is also going to help us scale this technology throughout the country. And just looking at the support that the government has already shown for this technology can help commercialize this technology on a very wide scale. As for the timeline, we would require funding and our entire timeline to be separated in 3 stages. Our first stage would be to establish research and laboratory simulations and rigorously improve our technology and patent it, and also connect with the government to seek allowance and potential to implement this technology on site. The second section would be to create a subsystem prototype model, conduct feasibility studies, and design and fabricate a system to ensure that the technology, when implemented on site, works in the way we want it to. And the last stage would be to install pilot projects on site, conduct more experiments, and collect data for a year, and then plan to scale it on a much wider scale so that this technology can be replicated throughout the world. However, enough data needs to be collected, a systems prototype needs to be created, and for that, it's a 3-year-long plan before we get the product out into the market. There are a lot of challenges that we face in terms of the monetary investments and the time to set up the plant. However, these are the same investments and time required to set up any coal or nuclear power plant would need. However, our solution sources lithium and generates clean electricity at the same time. There are concerns of geographical dislocation of communities and also some technological solutions. However, research and economies of scale will make this feasible with time. Other prospects include extracting other required metals such as nickel, cadmium, and so on from the same geothermal brine solution to manufacture batteries. And we can set up these extraction plants right next to EV facilities and partner up with these EV manufacturers to source lithium from them. Well, because these EV manufacturers are currently importing all the lithium into the country, and we can provide a solution so that we can scale up our lithium extraction in the country and produce and supply it to everyone in the country and export it in the future as well. Thank you for listening to a solution that takes us a step towards net zero, and I would love to have questions from you.
Great job, Aman. I'm going to go to Diane first this time.
Okay, I'll make this quick. The geothermal extraction is very intriguing. Are there any byproducts to the processes other than the lithium that you're hoping to achieve?
So as I mentioned, the geothermal brine, which is the solution that resides deep underground, has a lot of minerals and metals, including lithium, sodium, nickel, cadmium, etc. And a lot of metals are needed to create these EV batteries. So we can develop, this technology is currently focused on extracting lithium. However, in the future, it can be scaled and technology can be created to extract other metals as well, which are all going to be used in the EV battery.
Virginia.
Thanks for the presentation. That was really great. Wanted to understand, is it to create a new electric generating facility and then concurrently extract the lithium, or is there a way to add this onto existing plants?
Right. That's a great question. So this is a two-pronged solution again. So we can implement this technology by conducting, so we need to conduct certain feasibility studies to understand how we can directly implement and integrate this technology in current geothermal plants. However, the second solution can be to create new geothermal plants while keeping the lithium extraction in mind so that both the solutions are optimized for. However, the first one would take more time. The second one is the main focus for now.
Great. Addie?
Aman, so geothermal, DOE has made several awards in the geothermal brine extraction of lithium, such as American Battery Metals, Bear Minerals. So how does your technology compare with, the competition? For example, the DOE awardees going back to 2021.
Right. So as I mentioned, our focus is not just for lithium. It is to scale up to extract a lot of other metals and minerals as well. All the focus and whatever is being built right now is centered and focused towards lithium. However, as we know, in an EV battery, lithium is just one section of the EV battery. There are a lot of other metals and minerals which are not targeted towards, and this solution can definitely increase the conditions in which and improve the conditions in which metal is being mined, because just metals such as nickel and cadmium, which are not mined in the best ways around the world right now, need better ways in which these metals can be mined. So we are keeping lithium at the focus right now, and then we have the plan to implement and take this technology forward for a lot of other metals and minerals.
Great presentation, great questions from our judges. I need to probably come up with a better word than great, because it's not doing justice to the really incredible work of the students here. As we take the minute of transition, I also want to give another note to the judges that Jamie is presenting on the sustainable biofuels oilseed. They are noted as Audrey Wethington's team. For the judges, this was team 8. So they are going in the 7th position, but they are team 8. We had to have a little flip for a student who was taking a test this morning. So just to make sure that that's getting logged in the right spot. And then team 7, which is Peter Tran, the perovskite puzzle, will go after Jamie. So We'll do just a little bit more to let you finish your scoring, and then Jamie is going to be all ready to rock and roll. And this is the halfway point of our presentations. The time flies by with such interesting content. So great job, everyone. All right, Jamie, I'm going to start the clock and give you the spotlight, and you can get going.
Hi, so my name is Jamie Lyman. I'm presenting for Oilseed Growth and Management. Our team is looking to partner with farmers to create a greener future utilizing camelina seed. So what is our energy future? Our energy future is pretty dire at the moment. There are a lot of fossil fuel companies creating unsustainable fuels, and there are a lot of biofuel companies that are looking to replace those fuels with more sustainable sources of energy. They're looking for organic material that they can process into feedstocks that can be mixed with fuels. Here in Minnesota, ethanol is a great example of how corn is being used as a biofuel and is mixed into every single pump of gas as required by state law. So who are the big energy producers and consumers in this market? Well, there are airline companies that are looking to become greener and still use carbon-based fuels. And there are companies such as Gevo and Cargill who are looking to source any sort of organic material to turn into sustainable biofuel. And they are desperately looking for more supply because of this great demand coming from different biofuel consumers. So our technology is leveraging winter camelina. It's an oil seed that can be used as a cover crop, or it can be also used as a relay crop, and it does not impact the growing of cash crops that are common here in Minnesota, such as corn and soybeans. It grows well within the winter time, and so during the cash crop season, the growing of winter camelina will not impact the growing of the crops that farmers usually grow, such as corn and soybeans. While it grows, it of course pulls down CO2 from the atmosphere, and it is 80% more life cycle green than fossil fuels that are currently used. So what is the current supply chain for creating a feedstock? Well, it looks exactly like this, and we're looking to create the green in this diagram. And so by adding infrastructure to groups of farmers producing the winter camelina seed in terms of grain elevators that can store the seed, and also adding infrastructure to the biofuel refineries, creating oil presses that can press the fuel and then create sustainable oil as well as animal feed. This animal feed can be then given to farmers for additional use in their farms. So what does our business really look like? Well, it first starts with creating partnerships with farmers and building that seed supply. And then from that supply, we can build up and create infrastructure that can handle camelina future. And we will have fixed costs of labor and transportation of both the animal feed, and which is a byproduct of producing the sustainable oil from camelina seeds. We are looking to tap into this market of hundreds of millions of dollars created by the much needed demand for biofuel. So we see ourselves as this kind of middleman between farmer co-ops and refineries that need this source of biofuel. And our goal is to create partnerships and contracts between these two entities and make the energy transition smoother for both. So who's doing this? Well, we are a team of undergraduates here at the University of Minnesota across multiple different majors, from psychology, biology, aerospace engineering, architecture. And we are looking to create value for both of these entities. We are the link between farmers and refineries. And by creating this link, these entities can create more value in the energy sector, and also gives a voice to farmers who need to feel invested in this work. So our path forward involves partnering with farmers and getting a source of camelina on the fields currently. In Minnesota alone, there are millions of acres of farmland that have the potential to use winter camelina. And by tapping into a few counties' farmland and partnering with a biofuel producer such as Gevo and Cargill, we will then get that piloting investment and produce oil to meet that demand. We are hoping that the added infrastructure will then seamlessly integrate into the current energy infrastructure that we have today, just like the oil produced from corn in terms of ethanol. We hope to become just like that, another source of sustainable fuel instead of the fossil fuels we have today. I would like to thank everyone for listening to this presentation, and if you have any questions, I'm willing to accept them at this time.
Thanks, Jamie. Addie, let's go to you first.
So, Jamie, there are existing companies trying to do this. For example, Global Clean Energy Holdings recently won an award from USDA Smart Commodities, doing the exact same thing that I think you're describing as you want to do. And they already have that award, and I'm sure there are others. And they have, for example, GCE has, Global Clean Energy Holdings also has an agreement with ExxonMobil. Whatever biofuel they produce from their grower network, they will buy. So what's your differentiator? Why would a refiner come to you?
Yeah, that is a great question. So for two reasons. One reason is we need as many solutions to this problem as possible. And we are looking to go more towards the regions of Iowa and Minnesota instead of Montana that the Global Clean Energies Holdings is looking into. And the idea is we are expanding the infrastructure of Minnesota, Iowa, these places, instead of worrying so much about the production of the seeds and the oils themselves, which is what those companies are looking to do.
Okay, so you think there's place for more than one producer? Good.
Diane.
Thank you very much for the presentation. What is the efficiency of winter camelina as a source of biofuel compared to other types of biofuels on the market? And are there any concerns in fuel systems that would be required? For example, the higher the percentage of ethanol, fuel systems in vehicles or plants need to actually be upgraded to stainless steel to be able to handle it. So the question is on the efficiency of winter camelina, and then any accommodations that need to be done to use it as a fuel.
Yes, so this type of seed is very high in carbon, and so the worries of adapting current systems are very small. There's already been work done by, I believe it's the ASTM, basically the people who validate fuels, and they have validated the mixing of this sort of fuel into systems. Again, this research has been going on for about 10 years now, and so they have evaluated that. And in terms of efficiency of actually using the fuel itself, it is on par with other sources of fossil fuels.
Thank you.
Great. And since Jamie shaved a minute off the presentation time, there's another minute for questions. So Virginia, go ahead.
Great. Thanks, Jamie. Wanted to see if you could talk a little bit about the experience for farmers and if there is a big difference in how they process winter camelina, or, if there's a lot of that already in Minnesota, is it going to be a challenging uptake on that side?
Yes, so farmers will have to definitely expand the amount of work that they will do to process these seeds. There is still infrastructure to process things like canola oil seeds. And so it's just a matter of getting them to use their land more efficiently and planting more of those seeds.
Thanks.
Thanks, Jamie. Thanks, judges. We'll take that minute to log scores. And in that time, we'll have Michelle come on video and get slides ready to go.
Hi, Nina. Can you allow me to start my video? It looks like you stopped it.
Here we go, Michelle. Great. Okay, so Michelle will get slides up and ready to go here. Just a reminder to judges, this was a flip-flop between Team 7 and Team 8. So this is logged in HeroX as Peter Tran's team and the perovskite puzzle, and Michelle will be our presenter. And just give me a second here, Michelle, and then you can get going. Just want to get the spotlight on you. All right, take it away. We got 7 minutes.
Hi, everyone. My name is Michelle, and I'm representing one of the teams here at the University of Minnesota. Our pitch is about an economical approach to perovskite solar cells. And I know this sounds a bit technical, but the highest view is that we are taking two major innovations in the solar industry, namely perovskite technology and thin film solar cells, and applying a new processing technique, vapor phase deposition, to make these cells less expensive and therefore more accessible for all. So let's get an overview of what the solar market currently looks like. If you wanted to purchase panels to power a single family home here in Minnesota, that would cost about $13,000 in terms of buying the panels and having someone install them. I don't know about everyone else, but I, even though I'm a big fan of solar, don't have this type of money laying around to change over my energy system from fossil fuel-based energy into green energy. And this is a major issue. If we want to achieve our green energy goals, we need to make sure that everyone can participate in this transition. Part of the reason for these high costs comes down to the production scale. So when you're making solar cells, you often have to use high quantities of toxic solvents, and these can be expensive and make the process potentially environmentally harmful. Furthermore, on economic feasibility, solar panels are made out of silicon. While this is a pretty abundant and inexpensive material, the specific type that is used in solar panels, which are monocrystalline or polycrystalline silicon, are far more expensive. This raises the raw material costs and therefore raises the per unit cost for a solar cell. Finally, the energy goals and efficiency is a major issue in the solar industry. Monocrystalline solar cells on the highest end operate at about 20% efficiency. This means that you need more solar panels to power the same system. And for people with limited space, say you're in an urban area or you just have a small roof, this is not always a great option. These three factors stand in the way of having widespread solar transfer, so we have more people switching to solar. Our process can fix that. So we pitched that we are using vapor phase deposition to create thin film perovskite solar cells. Thin film solar cells have already proven their viability, though they're not made of perovskite material quite yet. Thin film solar cells aren't used residentially because you often need larger areas of land in order to capture the same amount of energy, making them not as desirable for residential homes. However, we believe we can fix that by combining it with perovskite technology. Perovskites are a relatively new addition into the solar market, coming in the past 20 years, but they're already on track to be competitive with or even outpace our traditional solar panels. Vapor phase deposition is the ideal way to scale this. On the production scale side, vapor phase deposition is a dry process, meaning that you don't use the same quantities of solvents. Because of this, the process is safer, more environmentally friendly, and scalable. In fact, we already use vapor phase deposition in the semiconductor industry when we're making computer chips. Because of this, we know that this is a very scalable and stable technology that we can use on a wide scale. Next, when we look into economic feasibility, you can compare the cost of perovskites to monocrystalline or polycrystalline silicon. You can grow perovskites at low temperatures in a lab setting, meaning that it's much easier to get these materials that you would use for the solar cells. Furthermore, because we are focusing on thin film solar cells, you use less material per unit, which means that the unit cost is driven down both from the material cost, but also from the amount of material you use in each of the cells. Finally, when we compare perovskite technology to traditional silicon solar cells, perovskites are going to win out. It's projected in the next few years that perovskites could reach nearly 30% efficiency. When you compare that to the monocrystalline silicon cells, that's a 150% increase in the efficiency. That means you need fewer panels on your roof and you can buy them at a cheaper cost. Let's look at the market. What you see here is the market specifically for perovskite solar cells. And it's a relatively small portion of the market right now because they're not currently being commercialized. However, it's anticipated they'll be commercialized in the next 3 to 5 years. As of 2020, it was $352.2 million, but growth is expected to be rapid, and by 2027, which is less than 5 years from now, it should reach $2 billion. For scale, the total solar industry is about $21 billion as of this year. We anticipate that these numbers on the screen are actually conservative because the perovskite market should climb and claim a bigger share in the overall solar market because they are competitive and will be more durable and cheaper than traditional solar cells. It's also important to note that there's an additional market here aside from just residential areas in terms of like government, aerospace, and transportation processes, because these areas often operate off-grid or with difficulties reaching a traditional power grid. Places like the military may benefit from perovskite thin film solar cells. Our target market would be companies that currently purchase and install solar cells and solar systems into residential or community projects. These are 2 companies that you can see often here in Minnesota. Because this is our target market, we operate business to business. So we fabricate the solar panels and then we sell them to these companies and they are able to provide more projects to their consumers. Instead of just offering one type of solar panel, they can offer multiple different systems that are accessible to people with various income levels. That's where our impact comes in. Our biggest impact is that we drive down the energy costs for consumers. In order to reach the clean energy goals set by both state and federal levels in the next 20 years, you need everyone included on this transition. Solar cells take maybe 7 to 10 years to pay off on that initial investment, but many people, especially those in lower income communities, can't afford to put down tens of thousands of dollars to transition their home to solar and to wait 7 to 10 years for that payoff. Therefore, our company is integral in allowing for this transition and satisfying the urgent need for large-scale manufacturing of efficient solar cells. With that, I thank everyone for your time, and I welcome any of your questions at this time.
Thanks, Michelle. Great job. Let's see. Let's go to Diane.
Thank you, Michelle. Great presentation. A couple of quick questions for you. One is, what type of incentives do residential customers have to convert their homes from fossil fuels to solar? And then thinking along those lines as well, what's the thickness of the thin film perovskite that you're looking at, and how long would it take to create a typical solar panel?
Yeah, those are really great questions. On that first one, we are aware that there are like some state and federal incentives that help people buy solar panels, and the $13,000 that I cited for Minnesota already includes the federal tax credit, meaning that it's still tens of thousands of dollars despite federal help in making that transition. We hope to lower the cost further and make it a more accessible transition for people. On your second question with regards to the thickness of the film and also the time it takes to fabricate, those would definitely vary on the process and what type of output you're looking for. So unfortunately, I don't have those numbers straight off the bat. Specifically on the processing point, this is currently only been seen in a lab scale, which is why we're pitching to create a pilot plant and allow us to get some estimates on how quickly we can generate these solar cells and how nice of a product we can create and pitch to our target market.
Thank you.
Yeah, thanks to you.
Addie?
What's the efficiency that you've been able to get in the lab?
Yeah, so on the lab scale, some studies have shown that you can reach the current efficiency of the monocrystalline silica cells, which are those that are, so there's polycrystalline, there's monocrystalline, and then there's perovskite. So on monocrystalline, they're the most efficient right now and the most commonly used for residential homes, and that's 20%. Typically 17 to 20% is what they typically
no.
say.
I meant your
Yeah.
specific technology.
Oh yeah, so we are reaching about 20% right now, but there's anticipated growth into nearly 30% in the next few years.
With vapor deposition?
Yes, so vapor deposition has demonstrated a stability on par with chemical deposition, as well as efficiency that is on par and planning to increase in future years with more perfection of the technology.
Yeah, just based on, maybe I'm showing my skepticism based on the experience of vapor deposition of silicon in the past, right? There was a trade-off between wafers versus vapor deposition on efficiency.
Yeah.
So this being another, ceramic semiconducting material, I'm not sure why perovskites would be an exception to that trade-off.
Yeah, I can, if you'd like, I can follow up with some papers I can take down your email or something like that.
Mm-hmm.
Thanks, Eddie. Thanks, Michelle. Great pivot from your test this morning. So you've had a big day. We have a minute for our judges to log scores. And then I believe Jian is up next. So if Jian wants to join us on camera and pull slides up, we'll prepare for that next presentation.
Hi.
Jian, not quite yet, please. Just give the judges a moment.
Sorry, apologies.
Put you on spotlight and then you can go, okay? They've got about 20 more seconds.
Apologies.
All right. And I'll have to say, as someone who has had an 8-year-old home all week, the idea of time actually having finite like start and stops seems very strange since where did that go here? Sorry, Jian, that's not what I meant to do here. There we go. Gianna, there you go. You start video and spotlight, and your 7 minutes is on.
All right. Can you hear us while we're setting up the PowerPoint?
Audio is good. Great.
Audio's good?
Go.
All right. Hi, my name is Gian, and I moved from the Windy City, Chicago to the Windy State, Iowa, which, if you didn't know, 60% of its energy is provided by wind, and I'm here to present on X-Crate, which is an Iowa State University company that is trying to improve current wind turbines. However, before we talk about how we can improve them, let's talk about where they are right now. Wind turbines are made out of steel with a typical height of 80 to 150 meters, with the majority of them being between the 80 and 90 meter range. And these are made through steel welding machinery line, transported mostly through streets to done at a tower assembly area, which will eventually become the wind farms we all know and love to drive by. However, there's a massive issue with today's infrastructure not being able to support taller towers. And this is because the taller they get, the wider the diameter is, which is leading to issues of it not being able to go through certain turns or it not being able to go under certain bridges. However, the solution is Hexcrete, which is a concrete module-based foundation for current wind turbines that would be done in a hexagonal manner that will be able to be built upon each other as shown in that second picture, which eventually, as shown in the third picture, the wind turbine will be able to rest on, gaining the additional height to get optimal wind flow and wind energy production. And it can be very clearly seen in these two graphs provided by the Department of Energy, with the left one showing that the difference between the 80 meter height and the 140 meter height being a 3 times increase in developable land area, and on the right showing that increased height also leads to a 3 times increase of wind power generation efficiency, which will be very beneficial for further wind power and wind generation and wind development. And For our market assessment, we mostly focus on the Southeast USA region, with us focusing even more specifically on South Carolina energy for a specific case study. And we saw that in South Carolina's energy breakdown was about 57.91% nuclear, with 21.97% of it being natural gas, mostly provided from out of state. And for offshore development, we saw that the Bureau of Ocean Energy Management recorded that a recent bid for 2 lease areas in the Carolina Long Bay was recently passed, with also the BOEM reporting that there's no ongoing leases or projects, showing that while there is still demand for wind energy, it is still a place that has a lot of place for growing and for Hexcrete to come in, which is where we can come in to meet that need of filling that lack of renewable energy, while also mitigating the reliance of out-of-state natural gas, which, as we've seen historically, has led to numerous issues, especially if anything happens to those pipes. Moving on to the economic feasibility with my partner Hunter.
Hi, I'm Hunter, and I'm going to be presenting on how Hexcrete plans to be an economically feasible revenue generating solution. First, so when towers reach that 140-meter height, they generate more power from the high-speed winds at those heights. And the levelized cost of energy is reduced by 6% when accounting for the increased costs of the larger tower and the increased energy generation. The logistical benefits of Hexcrete cause an 8% reduction in fabrication and transportation costs, and also allow the development of wind farms in areas that were previously inaccessible. The Hexcrete team also brings development expertise to wind farm developers who potentially do not have as much experience. Some of the beneficiaries of Hexcrete technology are wind developers, because it creates a new market for them, as well as local governments and energy providers, as they can transition their power sources to more green and sustainable initiatives, as well as the electrical infrastructure of the southeastern United States, which can often become strained as new technologies like electric vehicles become more common. Offshore wind energy can also benefit in conjunction with onshore wind development, because they can both combine to become a more influential part of the southeastern United States' power grid. The impact of Hexcrete would be nationwide wind access. The wonderful resource of wind would no longer just be accessible to the windy plains of Iowa and the Midwestern United States. It would also create a decreased reliance on fossil fuel and move towards a renewable resource, and reduce the need overall in our country for imported energy. The business plan of Hexcrete follows some conditions for success. Hexcrete needs to acquire 3 remaining certifications, as well as conduct a demonstration project to prove that this can be implemented. Implementation with Southeastern wind developers, there's been a lot of interest in this area, and they plan to monetize through technology licensing and design consulting. Some of the people and resources necessary to achieve these goals are Mid-American Energy, who would help with the demonstration, a partnership with a high lifting capacity crane company called Liftdra. Local southeastern governments and utility companies would help facilitate development. Concrete suppliers are an essential part of the supply chain, and Bright Moth Farms is who they're looking to do their first development with. This is the timeline for Hexcrete's certifications, and they're looking to form partnerships and begin to generate revenue in Q4 of 2024. Thank you, and we look forward to creating a sustainable future with Hexcrete.
Thanks, team. You saved about a minute on the presentation, so we've got an extra minute for Q&A from our judges. I see Diane's hand up, and then we'll go to Virginia.
Thank you. That was a great presentation. The Hexcrete sounds like a very interesting potential technology. I'm curious why you chose the southeastern United States for implementation, and whether there's potential to demonstrate this maybe earlier in Iowa or the surrounding regions.
Yeah, so the demonstration with Mid-American Energy most likely would take place in Iowa. The reason for implementation immediately into the southeastern portion of the United States is that high altitude winds in the coastal regions, there's a much bigger difference between the low altitude wind and the high altitude winds than there is in like an Iowa. So they actually produce barely any wind energy in the southeastern United States because they simply can't reach the levels to where it becomes economically feasible to do. And so that is where there's the most market need as well as the most desire to implement tall tower technology.
Thank you.
Virginia.
Thank you.
I also had that question, so thanks. And then was also interested if you'd done any like a carbon analysis of the differential between the steel and then the concrete for the tower.
I do not believe that. Are you talking about in the production of the tower itself?
Yeah.
So in far as the actual production, no study has been done. I don't believe it would be that much of a difference. Where a lot of the differential in carbon that has been researched comes in is in the transportation, because the large trucks that have to carry the big turbine sections have to be put on special longer routes to get around bridges just because of the infrastructure restrictions. Where with Hexcrete, they can use smaller trucks to deliver the concrete sections to the sites, as well as more direct and fuel efficient routes.
Building onto that, for the actual construction period of it, it's a lot shorter of a construction period due to them being able to simultaneously make the foundation while also them transporting the rest of it. So it lowers production rate versus like a traditional all steel 140 meter.
Thanks.
Got time for one more question if our judges have a question, otherwise we'll take the minute back in the program. Okay, good job, team. Give our judges a minute to deliberate, and then Colby, if you could come on video and get your slides ready. We'll give the judges about 30 more seconds and then we'll have you get ready to go. And we've got Patrick and Anna on deck after Colby, and then be ready for our keynote. So really, really great job, everybody. Okay, let me get you on spotlight here, Colby, and then I'm going to start your 7 minutes now.
Sweet. All right. Hello, everyone. My name is Colby. I'm with the group here at the University of Minnesota, and we're representing CARBA. CARBA is a scalable, low energy, and permanent carbon capture solution. So CARBA's mission is to become the main technology used for carbon capture technology to pull a substantial amount of carbon out of the atmosphere to help us limit getting to that 2.5 degrees Celsius or even 2 degrees Celsius warming. And our mission is to be able to remove 1 billion tons of CO2 from the air per year by 2035. And so we'll start out with our problem here. So our problem is industries that are unable to reach that net zero mark for carbon emissions, whether it's the steel industry, whether it's airlines, electric planes aren't coming anytime soon. So there are going to be some emission costs that just can't be eliminated. And as these regulations become stricter and stricter from federal and state entities, they're going to need to lower their emissions somehow. And so they're going to have to purchase carbon credits. So we want to be that supplier there to sell these carbon credits to these companies. And so how we're kind of different is we have these traceable form of carbon credits rather than planting trees or other types of direct air capture, which we'll get into the more of the technology on the next slide. But this is kind of the problem we're trying to solve, is bridging that gap between companies that can't have zero emissions and being able to fall within an operable range according to their location. So our main customer pain point, as I said, is providing a permanent, measurable carbon capture solution. So it's traceable. You can say, oh, I pulled 1 ton of carbon out of the atmosphere on behalf of this company, and it's traceable in a solid form. And so our solution with Carba is we're going to use plants to do the major, to take the major energy penalty when pulling carbon from the atmosphere. So usually with direct air capture technology, there is a massive amount of energy you have to use to pull such low concentration of CO2 from the atmosphere and turn it into a solid form. So we're basically using plants that conduct photosynthesis to take that energy penalty for us, and therefore our process requires much less energy overall. And so we have a patent pending reactor that takes biomass, so plants that have already conducted photosynthesis, and turned it into carbohydrates. And we take that and turn it into a solid form of that biomass and turn it into a solid form of carbon using a process called biomass torrefaction. And so we'll turn it into a solid form of carbon called biochar. And this biochar takes thousands of years to biodegrade and release that CO2 back into the atmosphere. And it's also resistant to bacterial and fungal decay. So hence being resistant to that decay, it's a stable form of carbon. And so when we compare this to other types of carbon capture technologies, our main point is that we're super low energy usage. The only energy required is to actually control, in our patent pending reactor, is to control the temperature in there. The biomass itself can actually self-sustain the reaction and create the heat necessary to turn the biomass into the biochar, which can then be deposited underground. Our cost is kind of comparable to other direct air capture technologies, but our main selling point is that our energy usage is extremely low. And this is really important for the future in analyzing the usability of a direct air capture technology, because with more electric vehicles and stuff, like there's a statistic where if every car was replaced with electric vehicle, the grid strain on the grid would increase by 30%. So the last thing we need is for a savior technology like direct air capture to even tax that grid even more. So our business model, like I said, we want to target businesses or companies that can't reach that zero emission point and still want to operate with their normal processes, like the manufacturing of steel and with airlines. And so we'll sell traceable carbon removal credits to these companies. And so we want to have kind of like a decentralized approach using many of these reactors and strategically positioning them so that we can simplify the logistics of moving biomass to these sites, having it go through the reactors, and then being able to store this underground. So we can kind of partner with waste removal companies that are already having this biomass allocated to them in the first place, and setting up these reactors in strategic positions and have a decentralized approach where we can consume large amounts of biomass and position these reactors in places where there's already biomass available or burial sites nearby. So this market is just going to explode over the next couple decades, as we're going to need this to curb and keep under that 2 and 2.5 degree Celsius of warming. And so we see this really growing with companies as regulations get more strict in certain regions and needing to fall within a certain range, as well as there's going to be more and more government incentives coming out, and we can kind of take a piece of those incentives and use that to help fund more and more investments into our technology. Another big upper hand of our process using our reactor is we can keep our prices per ton of carbon down to $100 to $200, which is drastically lower than any other direct air technology, while also being scalable on the large scale of pulling out eventually near 20 billion tons of CO2 from the atmosphere a year, which is what we're going to need eventually. And so kind of in conclusion, Carba's technology is super important. I think could really benefit from some more investments in the coming years by being super low energy and also not depending on other industries to change their practices. With a lot of these technologies that have real promise to affect us in the future, having a process that isn't dependent on totally revamping a steel industry, totally revamping the airline industry is super important, and can really allow for us to make the change and not have to rely on others to adapt. And so with that, I'm going to open for questions. Thank you guys for your time.
Thanks, Kobe. Let's see who's Virginia. Why don't you start us off here with questions?
Yeah, thanks, Colby, for the presentation. Wanted to understand a little bit better the sources of the material. So you're talking about like direct air capture. Are you having new stocks of plant material that you're leveraging, or is it existing biomass and then you're just ensuring that it, like, any waste material isn't going back into the air, but it's just, you know.
So so our plan is, so we kind of have simulations for every type of possibility. So if there's hundreds of millions of biomass available to be used every year, and that is sufficient for us, right? It's just a matter of getting it to our reactors. So our first case is kind of like grabbing this, whether it's from farms, whether it's from, taking down like forestry, stuff like that, is just getting it that way. And right now it's kind of free for us, but like eventually we're gonna have to pay for it. There is also the worst case scenario, which is having to allocate land and grow some type of plant to be the biomass itself. But even in those scenarios, our costs are still dramatically lower than any other direct air capture technology.
And then a quick follow-up. You're talking about, biomass sources being kind of all over. Are you anticipating a bunch of small modular setups where they would be at the site of the biomass, or are you anticipating trucking to a central?
So we're going to have a decentralized approach. There still is going to be some, type of trucking involved, but all of those costs for diesel and transportation is allocated into our costs, which we think can be somewhere in the region of $100 to $200, and pretty much on the low end of that $100 spectrum. So we like the decentralized approach, and most of our ideal reactor is on that smaller scale as well.
Thanks.
Thanks, Virginia. We have time for one more question. Diana, ready? Okay, thanks, Kobe. Good job. We will move on to, I think Patrick is our next speaker here, joining us from Wisconsin. We're going to give the judges a minute, Patrick, before you start, and then I'll give you a cue while they're logging their scores here.
Does my slide look okay on your end?
Yep, looks great.
Okay, cool.
About 20 more seconds, and then we'll let you get started, Patrick.
Yeah, no problem.
And again, for the audience folks, we've got these technology bonus prizes. So interesting to see all these different technologies. When we've got the Building Technology Office, Geothermal, Office of Electricity, Office of Fossil Fuel Energy and Carbon Management, Office of Nuclear Energy, Office of Technology Transition, Solar Energy, and Water Power Technologies offices. So again, having a wide representation of tech here in our region is really exciting as we think about competing at those technology bonus prize levels too. All right, Patrick, I'm going to put you on spotlight and going to start the timer. You've got 7 minutes.
Sounds good. Hi, I'm Patrick Sullivan. I'm CEO of Flux 12, and I'm going to tell you a little bit about what my team has been working on. So what we're ultimately targeting is a long-duration energy storage product for the grid. Why did we pick this market? Is one, is there's really no ideal product currently serving these customers. And two, if an ideal product did exist for long-duration energy storage, it could have a huge impact on our clean energy transition. It can reduce our carbon emissions significantly, and the first order estimate is about 1 ton of CO2 equivalents per kilowatt of long-duration energy storage. It can promote energy resilience and equity by reducing electricity costs. And we can also promote a more secure supply chain for batteries in the US by using alternative materials. And this is all in line with some of the SDG goals and the current Justice 40 goals as well. So why the utility market? Basically, it's because it's the biggest bang for your buck. We can have single contracts that generate billions of dollars of revenue. What's also great about these contracts is that they're typically multi-year delivery periods, which allow you to scale your manufacturing operations concurrently with the utility. The total addressable market is estimated to be over $200 billion by 2040. And this is as utilities will continue to install more energy storage to reduce outage risks, to reach policy targets by installing more solar and wind, and by ultimately reducing energy costs for their customers. Lithium-ion technologies are currently dominating the grid energy storage market. This is because they're really the only cost-effective technology at scale. However, if you talk to any utility that are even buying lithium-ion themselves, they all realize that lithium's future is limited. This is due to its supply chain risk, its short duration limitations, its complex engineering, and its fire hazards. And so what my team has been working on out of the University of Wisconsin-Madison is to address these challenges for utilities. My team includes myself, who's a chemistry PhD student, and also has an energy analysis and policy graduate certificate, Gu Han, who's a materials engineering PhD student, and Austin, who's a chemical engineering PhD student. And we have a really diverse research background to start addressing these issues with our technology. And so what we've been focusing on research for the past couple of years is on these long duration flow battery technologies. How these work is you dissolve your battery active material in water, and that is what's flowed through your battery to store energy. Over the last couple of years, we've screened over 500 chemistries in our lab experimentally, and we have 4 patent filings for this technology. What our specific materials use are abundant organics that are carbon, oxygen, nitrogen based. We have patented synthetic routes to make these materials using green processes. These organic salts are then dissolved in water, and that's what's being flown through our flow battery to store energy. Here's just a couple of examples of some of the materials we've been working on, including phthalagens as our analyte, which is the negative side of the battery, and TEMPOs as our catholyte, which is the positive side of the battery. And we've shown on the lab scale that these break the record for overall flow battery performance. When we're targeting the utility sector, the biggest risk that we have identified is that we just have to scale to tremendously large units to serve these customers. So we've tried to take initial steps towards de-risking this aspect. One, we're working on 1 kilowatt lab prototype in our lab, which would be about the size of a residential Powerwall, Tesla Powerwall. And we've also shown that those electrolytes, so those organic salts I mentioned, are indeed scalable themselves. We're able to make kilograms of those in our chemistry lab, which is already pretty impressive, but we've showcased that we can also make these in 1-ton industrial reactions. So we worked with energy firm DNV to kind of do an analysis on our technology, and they basically corroborated our performance with some key highlights here. So one is that our energy density is 3 times that of competitors, which will result in a smaller area footprint. We operate at much higher energy efficiency, over 80% energy efficiency, while most flow batteries are below 70%. And we also use a non-corrosive solution. Preliminary techno-economic analysis basically forecasts that once we scale to the utility size, we can significantly undercut the cost of current flow battery technologies. Kind of what we're doing next in terms of our commercial milestones is we're going to finish working on our kilowatt stack, which I like to think as the Lego block to building out larger systems. And I've started to try to form a network in the region to support these processes and had multiple conversations with these stakeholders, including Argonne National Lab to test some of their flow battery chemistries, Raytheon Technologies to validate our chemistry in their commercial flow battery stack. And we've also had some preliminary conversations with Intech Solutions, who's a division of Faith Technologies that does microgrid integration in Wisconsin. They're headquartered in Wisconsin, they do it across the country. And microgrids could really serve as an ideal beachhead customer. And then Alliant Energy, they're a large MISO utility that is interested in evaluating flow batteries to support their wind portfolio. So one of the questions you might have is there's a ton of competition. It's a very crowded space for grid energy storage, which we realize, but really why these partners are excited to work with us is they're realizing that we're the only potential low-cost option without any significant performance trade-offs that they have to sacrifice. And what this will allow these customers to do is to place these systems closer to load to improve energy resiliency. So I've given a pitch at the Smart Cities Startup Challenge on how these can be used for urban applications, just as supporting housing energy resilience and reducing energy burdens for low-income communities. And I also gave another separate pitch in Wisconsin on how these can be used in rural applications, including tribal nations, to support some of our critical distributed infrastructure. So yeah, so that's a little bit about Flux 12 and why I think you should go with the flow batteries. So thank you for your time, and I look forward to answering any questions.
Thanks, Patrick. I see Addie's hand up, so we'll start there.
Yeah, very impressive third-party testing from DNV, and very impressive list of partners, Patrick. I was just curious, to me, the advantage of flow batteries is, large systems, right, where the cost becomes more attractive compared to lithium ion. Given that, why would you consider microgrids as the beachhead application? As you said, wouldn't you compare less favorably with lithium ion in that application compared to larger stacks?
Yeah, so we definitely want to reach economies of scale to reduce our cost to be below lithium ion batteries. So in an ideal world, we would just raise a bunch of capital and build our own manufacturing facilities. But it's likely we're going to have to do some of these demo projects at the smaller scale first, even if they're not quite cost competitive at that scale.
No, fair enough. Thank you.
Yeah, great question.
I think he's saying you can solve it if you can just write him a big check, Addie.
Yeah, that is the answer.
Yeah. Other questions from our judges? All right.
I have a quick question.
Go ahead,
So you've shown the chemical potential of this. You've definitely analyzed the technology. You understand its potential and scalability. How ready is the market for another competitor in the LDES space? And I think that's the more, how well do you understand the market and your entry point and alternatives?
Yeah, so I think if there was a really good long duration energy storage technology today, people would just stop buying lithium for the grid. That's been how my conversations with utilities and microgrid customers have gone. I think that they're ready for it. It's just none of them are competitive with lithium right now in terms of their cost effectiveness. And one of the really interesting markets, I think, especially in our Northern Plains region, is to support wind portfolio. So multiple national lab and utility studies have shown that around a 20-hour duration battery really is ideal for pairing with wind, whereas solar is okay with that 6-hour lithium duration. But here in the Midwest, we might need more of this long duration option.
Great, thank you very much.
Okay. Thank you, Patrick. Another wonderful presentation. We are on our final presentation from Anna at the University of Minnesota. So we'll have Anna come on video while our judges are logging scores and prepare slides. And then Anna, I'll give you a cue once we have the spotlight on in just about a minute. And after Anna, we are going to pivot into kind of the second part of our program here. As I've mentioned, we're going to have an incredible speaker from the Office of Technology Transitions joining us and speaking to the intersection of business, innovation, and energy. I'm a big fangirl of Anna, so not to have any favoritism to the Annas, knowing that our next speaker is also Anna. So that's going to be great, and our judges are going to leave us to go deliberate and come back with our regional winner. So with that, let me get the spotlight going here, and Anna, your 7 minutes starts now.
All right, hi, I'm Anna, and I'm going to be talking about solar windows for agrivoltaic applications. So when it comes to the production and growing of fruits and vegetables, greenhouses have been used for centuries. And although there's a lot of benefits to using greenhouses made out of the traditional materials, such as plastic films or glass, we found that there's actually quite a few problems that arise when you're using these materials. The main issues are the energy use, the energy cost, and the extent of this cost. Greenhouses made from these traditional materials are extremely energy intensive, and energy costs typically account for the third highest operational cost for growers, and this can be up to 50% of total operational costs. So solar windows would decrease this energy use and cost. So how does it work? Solar windows use a technology called silicon quantum dots. These quantum dots are fabricated into a film sheet that can be attached to glass windows. Use of these quantum dots is beneficial for two reasons. Thin strips of photovoltaic cells can be attached to each side of a pane of glass to collect energy. The quantum dots are also able to shift the light spectrum in a way that can be beneficial for plant growth and increase crop yield. The customer segment that we would be mainly targeting is greenhouse suppliers. These suppliers would then be able to deliver our technology to the end consumer, the greenhouse owners, when they're designing greenhouses for them and getting those materials to them. We do have a few potential competitors in the marketplace, namely Solar Window Technologies Inc. and Soliculture. However, these companies don't focus on also boosting that crop yield. So we would differentiate ourselves from them by generating electricity while also optimizing plant growth. There are several reasons why we believe solar windows would be successful in the market. Solar windows will reduce land usage by combining greenhouses and solar panels together. They would also reduce the cost of greenhouse heating by using electricity generated from solar panels. Studies have shown that a greenhouse utilizing solar windows in a climate such as that of Arizona, where it's hot and a lot of direct sunlight, can attain a net zero energy consumption. The efficiency of these windows used in climates like this was so great that they generated surplus energy that could then be sold back to the grid and create an additional revenue stream for growers who have these windows. In climates such as Minnesota, it's not, they likely wouldn't get to this net zero energy consumption because we don't get that much direct sunlight, but it would still have a lot of energy savings. And so that's kind of why we would be looking at selling these to a more national greenhouse supplier, because our technology might work best elsewhere in the country, not necessarily the Midwest. Similar technology has received government funding, so we feel pretty confident that we would be able to secure some similar funding that would help us as we get started, scale up, and until that demand increases. We feel that this would have three major impacts on growers who choose to invest in these windows. They could save money on energy, even though these windows might be more expensive than using traditional materials like glass. With the savings that come over time from that reduced cost of energy, we feel that it would be worth it for growers to invest in this. It would maximize their land use and plant health. They would be able to generate electricity and grow plants on the same plot of land. And then also it would just aid in that transition over to green energy and help the planet in that manner. Our business plan revolves around maximizing simultaneous land use while also optimizing plant growth. Although there are a few people and resources that we need to make this business plan succeed, we would need partnerships with greenhouse manufacturers in order for them to really see the benefit of our product and why they should be passing it on to that end consumer. This technology is also not one that's really been produced yet, so we don't have a great cost estimate right now. So we would love feedback from potential customers on their willingness to pay, so that as we are developing that cost estimate, we can kind of compare it with that. Thank you for listening, and I'd be happy to answer any questions.
Thanks, Anna. Get you off spotlight here. And go to our judges for questions. Virginia?
I'll jump in. Thank you for the presentation. Can you talk a little bit about kind of the plan for the business, since you said you don't have the cost estimates? What are the next steps?
Yeah, so the next steps would, I guess, just be like producing those windows like fully. Like I know there's been like the components produced, but maybe not all together. So it would be that, and then yeah, getting that cost estimate and then getting that out to customers. Like I said, we'd be focusing on like greenhouse suppliers right away, but there's other applications that we've kind of looked at. So yeah, after that initial step, we'd maybe look at those other applications as well.
Thank you.
Diane?
I know this is very early stage, but do you have a feeling for how long the windows would last and how long they would be likely to produce a measurable change in energy?
Yeah, so they would be able to last like a very long time, like the same length as like typical greenhouse building materials. So they are very sturdy and would be able to keep producing energy for that time. So they would be a long-term investment.
Thank you.
Thanks, Diane. Any other questions? Okay. We're in that rare moment of running ahead of schedule, gaining a little bit of time on each session. So good job to everybody. Good job, Anna. I am really thrilled that we are just a little bit away from starting our keynote. I see she has joined us in the webinar. Just a few logistic things before we start that presentation. Good afternoon, Anna. We have a survey from Office of Technology Transition that I know we've got folks who are in attendance who are from your teams, as well as obviously our speakers. So I'm going to add that link into the chat here. So, this is the second year of this program. I will just advocate again that I think this is not working. Give me a second here. There we go. So I really would like all the teams to take a few minutes here while we're getting ready for the keynote and just fill out this survey. Your feedback is really important. This program is intended for you as students to have a really incredible experience, to learn more about entrepreneurship and business planning for emerging tech. It's only the second year, and I've already seen a lot of improvements from last year, which was a good starting place. And we want to be able to continue to grow the program. I can definitely say one of the things I'm looking for is how can we get more students involved, especially up here in the Midwest? How can we get more colleges competing? I want to really see our region be a very strong region for this. And I think one of the ways that we grow is by making sure that we're creating a good experience for you as students. So your feedback matters. This program is really important, but your experience within that is critical. So please take a moment with that. Also, Dan put it in the chat, but just really, really incredible job by all the teams today. I'm super impressed. I listen to pitches every day. And, I hear them from folks who are at all different levels of development, from all different backgrounds. And to be able to say that the student pitches are competing with some of the most advanced technologies and startups that I work with, just really shows how well you all prepped for this and considered what the judges are considering. I know some folks have a little bit more technology background than others. Some have more business background. And I think being able to find that sweet spot is really important. And I think y'all did a great job with that task. So again, the form is in the chat. So please do take a moment with that. If you have any feedback for me as a convener, I'm always open to what we can do better. I know that we work on a really tight timeline with this. So hopefully that's something that can continue to get better each year. But considering how fast it all came together, just again, really commend the students for a wonderful job. And then before they go to deliberate, I just want to thank our judges again. I know you are all really busy people, and to take 3 hours on a Friday after a blizzard week in Minnesota and for Diane getting over being sick and be here with these students. Your questions were just such a reinforcement of your expertise. Really fantastic questions, getting us all thinking about what does it really take to make these things work. So just I'm going to thank you a million times, but just one more before we transition here to the next segment. So you'll head over to the other Google link, and Hannah from OTT will meet you over there to review scores. And we'll see you back probably around 12:55. If you get done early, come back and hear Anna's presentation. We'd welcome you back into this room. Text me if you run into any challenges. So thanks, judges. And with that, I am so excited to make this presentation of introducing Anna. Just an incredible leader in this work, someone who I admire and just look for every I'm going to call you every time there's an opportunity, just because I love to hear you speak and you have such an incredible subject matter expertise. I'm going to drop our speaker's bio into the chat. Or I'm going to try to, we'll see if I can be technically savvy enough to do this today. And it's not going to work. So I'm just going to read this quickly. She has spent her career making the business case for energy efficiency, climate tech, innovation, and building performance as a means to address the world's most pressing energy challenges and the global urgency of climate change. On leave from Carnegie Mellon, she is currently serving as senior advisor to the U.S. Department of Energy's Office of Technology Transitions, also our EnergyTech UP hosts. After nearly a year as commercialization executive to the same office, in 2023, she was appointed delegate to represent the United States on Mission Innovation's Technical Advisory Committee with a focus on zero emission shipping, industrial decarbonization, and the green powered future. Because those are each small categories, right? Just a little bit there. She served on DOE's International Affairs Leadership Team that brought the Global Clean Energy Action Forum to Pittsburgh, PA in 2022. In 2020, she was appointed as U.S. DOE Ambassador, Clean Energy Education and Empowerment, C3E, by the Secretary of Energy. I'm going to try and get through putting the rest in here just so we can get to you actually starting. But just absolutely my pleasure to welcome you today, Anna, and thanks for being with us.
What I'd rather is just people can connect with me on LinkedIn if they want to. That's probably the best thing to do.
You just need to get them as in awe of you as I am.
We all are working really hard, and I think that's an important part of this. So we're still 15 minutes is what we need, right, for the judging?
15 to 20. So take your time here.
Great. Let me. I have some slides I'm gonna share.
Great.
Okay.
And I'm gonna just put you up on Spotlight there.
Let's see. Hold on. Sharing my screen.
Great.
Need to. Okay, so first off, thank you, Nina, for your kind words. There's a lot of interest and enthusiasm around this space, and I'm particularly excited to be here with you all today. I am just going to talk for about 15 minutes. I have a lot of content to cover. A lot of it is kind of new, and so I've been sort of brushing up on it. I welcome questions at the end. Certainly, if you have clarifying questions, you can interrupt me at any time, but I can't guarantee that I will see the little hand when you put it up. But thank you to Nina. I'm especially thankful that Anna went right before me, so you have two Annas right in a row, twinning. So let's see if I can get my screen to work. So this is my contact information, just really quickly. please reach out to me at any time. This is actually my personal cell phone. And I am pretty active on LinkedIn. So if you would like to connect with me on LinkedIn, I would love to hear from you. I have the significant disadvantage of not being able to see any of you today. So I don't know how many people are on the line. I don't know how many of you are engineers or non-technical in terms of your pursuit of energy, but I definitely would love to connect with you and we can always talk further. So the first thing that I want to say is congratulations. All of you have been participating in this incredible day. I hosted this day before when I was at my last job at Carnegie Mellon University. I know exactly what it takes to pull everything together, to have all the content and the material and to learn all these new things, to learn about a new company. But I just want to thank you all for everything that you're doing, because my hope for the EnergyTech UP is that you can now envision yourself as a person who's going to work in clean energy. Maybe you thought about that before, maybe you were planning on working in energy, but maybe you weren't exactly sure how to get involved. And so doing this competition, which OTT is kind of like the engine behind, is a really great stepping stone for you to get into clean energy. Climate tech innovation, energy, there's so many different component parts of it. And I hope that you will seize the opportunity that today provides to you, because I'm sure you know that we are at this critical moment in time, in history. It's perhaps the most important moment in our history because we're facing a climate crisis. It's urgent. And I feel that urgency every single day. And we need to act within the next 10 years. Because COVID and the geopolitical events have really disrupted the global supply chains and energy resources. And the Biden administration has come along, which I'm going to skip to. Oh, my slides are going to go slow. Okay, so the Biden administration has come along and they have had a partnership with my new boss, Secretary Granholm, to set bold decarbonization goals, but with a vision to have an equitable transition that creates jobs and strengthens supply chains and domestic manufacturing in ways that we haven't seen before. So it's estimated that we're going to need about $10 trillion with a T in order to achieve net zero by 2050. So more than 20 emerging technology categories are really going to have to commercialize, which means moving across the research, development, demonstration, and deployment continuum. We call it the RD&D continuum to get to scale. And that's going to be about $100 billion per energy sector. So there's going to be jobs, there's going to be opportunities. So it's this new interdependent system that has to transition the coordination across industry, government, and communities. But because each technology faces such complex barriers to deployment, it requires intentional coordinated action. And that is what my office does at the Office of Technology Transitions. We work with public and private partnerships to create enduring markets for technology solutions. So the DOE and the United States government are working to enable the transition through public investment and policy, but the private sector, including companies like ones that you might work for in the future, will need to pull investment forward as well. So in other words, no matter what path you choose for your future endeavors, you're each part of the solution now. Consider yourself engaged, consider yourself a part of it. I want to back up really quickly because I want to show you that my path was really atypical. If I could find it, if my slides will go backwards. They're going in the wrong direction. Okay. Hold on one second, please. Technical difficulties.
We've got plenty of time.
Nina, I can't figure out where they're going. All right, so I'm just going to start here then. So what do we do in the Office of Technology Transitions? We actually have this funding in R&D, research and development, and we're now using it to hit strategic goals to foster partnerships, so public-private partnerships to move different solutions forward. Let's see if I can move to the next slide. Okay, so what does that mean? You have this sort of push-pull that's happening with the market around any different kind of technology. So the goal ultimately is to have market viability for any number of different technologies. But it requires market thinking, and it also requires funding. So a lot of times when I give presentations, the first question is, well, how much money do we have for this? Well, as it turns out, with recent legislation small offices like mine, the Office of Technology Transition, has $123 million than it did before. So we're running all kinds of different programs that you might have heard of. Some of these you may not have heard of, and I'll talk a little bit about them when I talk about kind of opportunities for the future. But there are quite a few of them that are directly related to things that you're going to be doing. So when I talk about research, development, demonstration, and deployment, I wanted to sort of show you what that looks like, because a lot of people want to know what the steps are, how that works for an individual technology. Because right now, you all, with your technologies, the things that you've been talking about with your business plans, are really at that very beginning stage. You're at sort of a TRL level, technical readiness level 1. That's the very, very beginning. But you can see that you go all the way through 9 as you're developing the technologies, developing the company, developing the idea or the concept. And so you really are de-risking different parts of the problem at different times. So it could be that you're de-risking the finances, or you're de-risking the technology itself, but you have risk that remains all the way through the process. So a lot of folks also are curious, well, how do we work with organizations or companies or startups? So we sort of go across the entire spectrum of all of those different TRL levels. And some of you might have heard of ARPA-E, you might have heard of a new office called the Office of Clean Energy Demonstrations, and they're all sort of helping to de-risk the technologies at different places depending on the scale. So the Office of Science is the one that starts very, very basic. And then you get all the way into the Loan Program Office, which starts funding opportunities at about $100 million. So you can see that there's like a full range of opportunities for any particular technology. And the reason that there's all of those different people involved is because we have these valleys of death. And I'm sure that you all have heard about these. So a valley of death means that you get to this point where if you don't have enough capital to get to the next step, you're going to kind of have this kind of stopping point. And so as you're moving from basic research to applied research, development, demonstration, deployment, which is scale, you have these different opportunities to get mentoring from folks like me and like Nina. So our priorities are around building capabilities, making sure that capital is available, ensuring that there's collaboration so that people work together, understanding the context so that when something lands in the market, it's actually, the market is ready. It has an understanding of what's coming. And then there's contracting mechanisms as well that get the public-private partnerships together. So we also have a number of sort of key initiatives that we're working on, and I'm going to really focus on one of these today. You guys can hear more about the new foundation, which will be the 17th foundation that comes out of the comes out of the federal government. There are other kinds of mechanisms about stakeholder engagement. What I really want to focus on today are pathways for commercialization liftoff. And the reason is really exciting, and I'll sort of get to that as I go through. So today I'm going to talk about 4 technologies in particular, because I wanted to sort of really focus on a couple of areas that might be of keen interest, particularly to those of you who are thinking about getting jobs in energy in the next couple of years, because these areas are the ones that are exploding. So there are 4 I'm going to go through today. The first one is hydrogen. You've heard a lot about it, but there are some pretty specific goals set by the federal government, by the DOE. There's what's called a shot, these earth shots or moon shots. The hydrogen shot is actually trying to reach $1 per kilogram of clean hydrogen within a decade. And so it actually has step down goals as well in terms of millions metric tons. So we're really trying to get to a 0 or near 0 emissions. Now, hydrogen can be made from any number of different feedstocks, whether it comes from renewables or nuclear or natural gas, but there are all these different ways that we're trying to kind of move forward on hydrogen, including 8 hydrogen hubs that will be coming up in the United States. They're all kind of out right now for funding. We've asked for proposals. We've received them from all over the country. And you can see these sort of hot areas around the country that actually are beaming or brimming, I should say. And the interesting part of this is actually Texas is a very, very hotbed for hydrogen, not shown in this map. Second area, this is an area that I do a lot of work in, is long duration energy storage. And so this is the idea, the goal is that we're going to have long duration energy storage reducing the cost of grid scale solar storage, which is for utilities, by 90% to deliver 10 hours of duration within the next 10 years. So similar in that sort of time frame, 10 years. So there's a lot of work that has to be done because we can ensure resilience and we can actually have more reliability in our grid if we have long duration energy storage. We're tracking somewhere between 30 and 80 different technologies in this space. And the levelized cost of storage is another sort of hot topic that a lot of people are talking about as well. The third area is advanced nuclear. And so the goal here is to scale to 200 gigawatts of new US nuclear by 2050. By the way, this nifty graphic on the side, there are posters that the Loan Program Office puts out. So if you're looking for nice decorative art for your college dorm room, you can just download these. They're awesome. I think there's 10 or 15 of them. Anyway, we're trying to find kind of off-takers for nuclear in the United States, but we're at sort of a stalemate. And so there's a lot of interest in nuclear in terms of propping it back up with small modular nuclear reactors and other new technologies. And then finally, area number 4, carbon management, which is actually sort of the umbrella topic for carbon capture, carbon dioxide removal, transport and storage of carbon. What we're trying to do is actually get to less than $100 per ton in the next 10 years. So the same sort of thing in terms of an earth shot. And there are hundreds of millions of dollars available for projects and research in carbon management. So the reason I focused on those 4 is that my office, OTT, is doing these liftoff reports, and they're launching in about 2 weeks. So this was a bit of a sneak peek against something that's happening at Sierra Week. And if you can ever get yourself to Sierra Week in Houston, it is an incredible opportunity to meet people. But we are really looking at how to pull out information in these 4 areas. And then soon we'll start industrial decarbonization, VPPs, which are virtual power plants in the grid, and energy improvements in the rural areas, as well as supply chain related issues. So there's a lot of important research that's happening at the department, and this is sort of across the entire organization, particularly working with clean energy demonstrations, Loan Program Office, the Office of Electricity, and the Office of Policy. So what we did with the methodology on these 4 reports that are coming out, and I can't wait to have you download them, we can send them out in a couple of weeks, is we're looking at the current landscape for commercialization, and we're trying to figure out what are the barriers, what's the cost, what's the willingness to pay, what conditions have to be ready in order for people to adopt these different new technologies. And so we're also creating a shared language and fact base so that people can communicate with one another with goals and objectives so that we can all be going towards the same kind of goals to meet basically the climate, what the climate change crisis requires. So how can you get involved? Checking my time here. There are a couple of ways that you can get involved. One of them you've already done. Congratulations. It's to do the EnergyTech UP. I think it's one of the most interesting prizes that we run. There are hundreds of people. You are now joining them as sort of alumni of this program, and it becomes kind of a network for people who are interested in energy careers. The slide that I didn't show you at the beginning was to say that I have a very different way that I got to where I am, very non-traditional. I wasn't trained as an engineer, and yet I work in a highly, highly technical field. So it is possible to enter this arena in a number of different ways, and you have just tapped on one that is really, really great. Next, there are organizations around the country that have funding and that hire people, and they are part of our program called EPIC, which is the Energy Program for Innovation Clusters. These are the sort of the dots. That was the first year when there were winners. This is the second year when there were winners. This is the third year when people have gotten this prize. And what it means is they have funding to foster innovation and technologies, including startups in the local area. And this is a better shot because it tells you some of these organizations that have been given this money to build ecosystems in their regions. So it's a great opportunity to look up, like figure out where you want to live in the future and where is the innovation cluster that you can connect with to keep driving your technology forward. Third, we run an internship program. The applications did just close in February, but we will be running it again. So those of you who are not seniors who would like to consider working on working at a national lab, sometimes virtual, sometimes in person. I think we're allowing people to choose when they'd like to, or whether they'd like to be in person or not. But you have this opportunity to learn from this incredible lab network of different technologies associated with the clean energy spectrum. So we've had 2 classes. We've just, as I said, closed the application for the 3rd, but you can see that we have people at sites around the country. Some people have gotten jobs, some people have worked on projects together. There's a joint venture that's come together. So some pretty interesting things happen when you work with the national labs. And by the way, this is kind of the snapshot of the 17 national labs. Sometimes you might have heard of one of them, but not known that it was a DOE national lab. 17 of them around the country. Each of them has hundreds, if not thousands of people working on energy related technologies, everything from biogas to traditional fuels to energy efficiency, building environment, et cetera. So no matter what your interest is, there is a national lab that is working on something, and it is a very easy search. You might have actually already found them through the lab partnering service. So I know that we talk about the lab partnering service, but I have become intimately familiar with this particular tool. You can actually go in on your phone or on a computer, you can type in a keyword and you can find every person who's working on that kind of technology. So you might have a startup that you have in mind, you've been inspired to do something new, but you don't quite have the technology behind it. You don't exactly know who might be the right person to talk to. You can actually look them up. It has their email address. You can reach out to them and you can figure out a way to continue working on your technology or whatever new technology you were inspired by along the way. And then finally, you can work for the Department of Energy. I encourage you to stay in the energy field, but I do want you to know there's a new resource and it's called DOE STEM. And it actually is kind of a central repository for all jobs associated with the Department of Energy. We are hiring thousands of people through our Energy Core program. But this website now has a lot of those positions listed. It even has things for K through 12. So if you have a sibling who's also interested, you can get them involved. And that's a pretty easy website to remember, DOE STEM. So with that, I would love to offer the opportunity for any questions. Just a quick run through. And again, there's my contact information. Please connect with me on LinkedIn, and I'd love to hear if you have any questions.
Thanks, Anna. That you covered a lot of ground in a short amount of time. I really hope some of our students, either those who were the speakers, feel free to come put your video on and be part of a conversation here and ask your questions. I'm gonna ask you to go back, and I know you don't have the slide, but will you just speak to, I think your background's really interesting, and you're right of kind of how you weave into a highly technical position. So I don't know if you could just give us a snapshot of that, of your story.
I can actually go back to it.
Okay.
Let's see if I can do that. Hold on.
Yep, no problem.
I think I'm not sharing right now. Is that correct?
Yep, you're not sharing right now. Yeah, so you can go back to that slide and come back on.
Yes, it was in the middle of my technical difficulties.
Okay. And I'll also note for folks just thinking about those opportunities, I had actually one of the students we had working with Grid Catalyst this fall who helped us with our initial recruiting for the EnergyTech University Prize is now has an internship secured with the DOE Weatherization Assistance Program.
Fantastic. Love to hear it.
So yeah, we know that there's lots of opportunities there, and I'm glad you're emphasizing those, but I'll let you speak to this.
I know it is a kind of a kooky story. So I started at the Home Depot on their e-commerce website, the first e-commerce website that was coming up in the United States, which is kind of kooky, dates me a tiny bit. But it's important because I had no energy background before that. I literally learned everything on like working in stores, going to manufacturing plants, going on rooftops. And I really just sort of dug deep. If I unblurred my screen, you could see that I have this enormous bookcase, 2 of them I had to get because I have so many books about greening buildings and carbon pathways and that sort of thing. So I'm sort of a super geek, but it started by just learning about the products and product procurement at the Home Depot. I became the global product merchant because I self-educated myself all the way into knowing the most about anyone at that enterprise at the time. So I left there and I worked as a consultant for about 10 years on the Energy Star program. So it was about 10 years in Atlanta, then about 10 years in Washington, DC. I worked at ICF, which is a company that a lot of people like to work for when they are starting out in energy fields. And I supported Energy Star across about 60 different product types. And again, it was just, I would go and I would sit and I would ask questions and I would learn about the different technologies. And I would put my technical know-how up against, a lot of people, because it's pretty tough when you're working at the Home Depot and then you're working with manufacturing partners. I then ran a building efficiency program called a 2030 district. I ran the one in Pittsburgh and I grew it to about 500 buildings, about 84 million square feet, running a voluntary program. And then I went to Carnegie Mellon and I ran an energy institute for 6 years. So that was working with faculty members on everything from very, very basic bench science all the way to startups, lots of startups. The startups that I talked to, mentored, and worked with, they had about $313 million in follow-on funding while I was there, which was that's like, I'm very proud of that because that was a lot of work, really good. And then last year I was asked to do public service at the Department of Energy. And so that's where I am now. I work on long duration energy storage. That one slide I showed you, I could have had a lot more in that particular one. So I travel all over the country and I talk to companies that are starting their technologies and I track all of those technologies. I work with people within the Department of Energy to figure out what industry is really looking for, because the last thing we want is to create a widget and then not have a place for the widget to go. And then as of about 2 weeks ago, I picked up the international portfolio. So that's why I have these new designations and will be traveling a lot more. So I was not an engineer. So those of you who are not engineers, we have lots of things to talk about.
Yeah, I think the thing I love about this and also why I love talking with students is, for me, when I first started an environmental science degree, I was studying conservation biology and wildlife science. And I thought that was going to be, and I didn't even know this whole realm existed, right? So sometimes it's not until you get those experiences, you're like, that's fascinating and I love it and I'm good at it. And then your whole experience starts to evolve in a totally unpredicted.
Yeah, you really never quite know where it's going to go. And it's just a person that you met at a conference one time, or, that you happen to admire and reach out to them and ask them a question. And the next thing you know, you're working on a project together. So I see a question here that says, does the DOE OTT work with state and local governments to facilitate new technology adoption? I would love to answer that question. So we do work with incubators and accelerators. And then we have a brand new office that sits very close to us, which is called State and Community Energy Programs, SCEP. So SCEP actually has the jurisdiction to work with communities, which includes state and local governments. Now, that's not to say that we don't. So I live in Pittsburgh, Pennsylvania. So I work with the local government here because I know them and because we lean on each other and we ask questions. But we don't specifically work with state and local governments per se. I can imagine that if they asked us to, we would, but it doesn't exactly kind of mesh that way like I would like it to. But I'm open to it if we can figure out a way to do a partnership where we're helping multiple states, because that's the other thing, is that an interesting thing about working for the federal government is you can't pick favorites. And so in not picking favorites, it is challenging when you're working with just one state. So I can work with 3 states pretty easily.
Yeah, thanks for that answer to that question. And, certainly for those who haven't worked with Department of Energy before, I think there are so many departments doing really interesting things within the Department of Energy and, the loan office and some of the other technology offices and the labs. There are partnerships that are happening at the state and local level. that are just flowing through other parts that still relate to emerging technology deployment, funding research and development. So, you know, it's not a lack of presence for DOE within that. It's just OTT's focus is just a little different. Right?
Yeah, it's like how we are, our mission is around pulling out technologies from the national labs, from university partners, and from incubators and accelerators. So that's like, because we have a mission, we try to stay in that lane because there's enough work to do.
Yeah, great. Well, I'm so grateful for you being with us today. Thanks for sharing. I think I'm glad we recorded, because I want to go back and look at some of those key technology priorities and some of the other things that you shared today. I bet our judges will want to go back and hear from you, who have just joined us from their secluded, you know, confidential space.
They're back.
So, yeah, they're back. So, well, thank you so much. I wish everybody was on audio so you could get a round of applause, but thanks for being with us today. And you're welcome to stay while we get an announcement of our regional winner.
Well, let me just really quickly, one more time, before you make the announcement, just congratulate everyone for your hard work. So it's an incredible thing to pull this together in such a short amount of time. I have seen what it takes. I have seen the pain of students when I was at Carnegie Mellon, when they were working on their technologies and trying to figure out how to put together a business case. And so I applaud your teamwork. You're sort of grabbing onto new technologies and to undertaking something with a lot of faith, right? So I appreciate all of your time, and I'll see you again. Please connect with me on LinkedIn if you would like.
Thanks, Anna.
Thank you.
For folks who were looking for that, I have her link in the chat, and just gonna echo her admiration for everyone. Lots of hard work. Again, we're gonna have a winner, but I think really, I hope the experience has been rewarding for folks, and you have just so much to be proud of in what you've accomplished in such a short time. And I know for those of you coming out of the labs, your work is going to continue. I hope for folks who were a lab adjacent team, this really was an enlightening experience of where you might go next, or how you might continue to work with the lab that you met during this project. With that, I don't know who gets the mic of our judging team here, but really excited to hear how the scores have tallied.
Nina, I'll say that we had some really great discussions among the judges. I also want to add to the comments that congratulations to the teams. There have been some extraordinary efforts on this, some incredible work, and you've all done a terrific job of looking at everything from the market feasibility to the technology to the business plan, and really putting together a comprehensive package. Eddie and Virginia, are you okay with me announcing it?
Yes.
Yes.
All right. Then I would like to officially congratulate Flux 12, Go With The Flow Batteries, as our regional winner for the Northern Plains. Congratulations to all of you, and it was really exciting to see the pitches today.
Thank you, judges. Thank you to our team, Patrick coming in from Flux. Now I feel like I can make the flux capacitor joke I've been wanting to make the whole session without. That's great.
really
Patrick,
appreciate it.
anything
Thank
you'd
you guys
like
so
to
much.
say?
No, I just really appreciate it, and want to thank my team at UW Madison for all their work on this too as well.
Good, thanks, Patrick. I'm going to ask, I have the judges and Patrick on a screen together right now, so I'd just like to do a screenshot, and that way I'm not catching anybody mid-sentence. So we'll do a quick picture here, so Patrick has something for a good memory to share with the team. 1, 2, 3. Great. All right. Well, thank you, everybody. Patrick, I'm sure there'll be a follow-up specifically. I'm glad Hannah could be with the judges today. Thanks, everybody, for the time. Judges, I promised I'd thank you a million times, even though I know that doesn't have a cash value, but you've got a lot of gratitude from me. I really appreciate the time. I'm sure it was not an easy decision, as fantastic as the Flux team and Patrick's presentation was. We had a lot of really great competitors today.
Nina, one comment is that we've also nominated a number of the teams to move forward with the additional prizes. Hannah took notes and has sent that to you over email. So if you would like to announce any of those, you're welcome to.
Well, I see Joe Simon has joined us in the room, so it sounds like that would be okay to announce technology bonus prizes if you have them.
You actually have them. They're in your email.
I have them. Okay. I have them in my email.
According to Hannah.
There it is. Oh, all right. So we've got several. So I will have all these folks come on camera if you're still in the room. So thanks for getting me in the right direction, Dan. All right. So in the and again, these are nominees for the technical bonus prizes. So in the carbon dioxide removal nominee will be Carba. Kobe, if you can come on. The solar energy nominee is the UW-Madison Helios. In the geothermal, we have a geothermal nominee for the clean extraction of precious elements. I think Aman had to leave, so I don't know that he's still there. And then in grid enhancing technology, we have Flux back in the room. So if Kobe is gone, maybe I could just get Patrick to come back on if he hasn't run off. Great. So that's exciting. We've got 4 folks who will move on to that technology bonus prize. Just checking the chat quick to see if Joe or Hannah have anything else I forgot here. Great. So congratulations, everyone. I'm really excited that we have these. I'm going to do one more screenshot because I'm nerdy in here to make things like awkward family photos. But all right, on the count of 3, 1, 2, 3. All right, thank you everybody so much. I can't believe what a great day it was. We stayed on time and on mission. Everybody has a lot to be proud of today. Don't hesitate to reach out to me or, Joe and Hannah and the team at OTT want to be there to support you. They're trying to be there every step of the way to let you know what you need to know about next steps. And for those who are still going to be in school next year, I hope you'll consider competing again. And then lastly, I'll say if you're interested in this space and you're not sure if you want to reach out to Anna yet, you have my contact information. I'm always happy to talk about what the career opportunities are, where you can go next, introduce you to our judges, anything else. So great job, everybody, and have a fantastic weekend. Thanks. Bye.
Congratulations.
Thanks. Bye.